There's a quiet that comes down when the darkness suddenly comes.
It was like you could feel the shadow coming over you.
The air was so clear that we could just see these streaks moving huge distances across the sky.
You feel it in a way that feels so different. The images don't do it justice.
And then you're just sort of locked in.
When you experience an eclipse, you feel that connection with space.
Oh my gosh!
Oh, look at the ray structure!
The universe is out there and it's affecting us. We are in space.
And here it comes, there's the diamond ring. And that is the most spectacular sight.
If you haven't seen it, you haven't seen anything.
Hello, and welcome to live coverage of the celestial event of the year, the total solar eclipse. Over the next 3 hours, we will follow the moon's shadow as it races across North America. We are anchoring our coverage from the heart of downtown Cleveland, Ohio, just down the road from NASA's Glenn Research Center, the only NASA center in today's path of totality. I'm NASA's Megan Cruz, and this is NASA lunar scientist Sarah Noble.
Hello.
Today, NASA and the Great Lakes Science Center is hosting this free outdoor event for the community to experience the total solar eclipse together. You saw that beautiful aerial shot that we just had opening the show. We're seeing it again here. As you can see, we have a great fun crowd here.
Yeah, we've been watching the crowd build all morning, and you can really feel the excitement starting to come now.
Yeah, absolutely. The watch item, of course, is the weather. Beautiful right now here in Cleveland.
It's perfect right now.
It's perfect, yes.
We woke up to rain and it cleared, but I don't know what we're going to get this afternoon.
Yeah, Sarah, you said that with a little bit of trepidation, and that's because it looks like there might be some cloud cover around the time of the total solar eclipse here, totality, but we'll see. All right, so on your screen now is the first look at the eclipse from Mazatlan, Mexico, one of the first communities the moon's shadow will darken today. Right now, you see we're seeing a partial eclipse of the sun right now, but if you look at the upper left-hand corner of your screen, we're expecting totality there in about 1 hour and 4 minutes. And we want to thank our team of telescope operators spread out across North America. Because of them, we will always have a view of the sun during this entire broadcast, which is
That's
really
right,
awesome.
all the way from Mazatlan up to Maine.
Yeah, a very large swath, and we have it covered the whole way through. Now, if you scan your QR code that you see on the screen here, it'll take you to a live stream dedicated to just those telescope views, and it'll also take you to a Spanish broadcast of today's eclipse, and that starts at 1:30 p.m. Eastern Time. And Sarah, as you know this, all of the telescopes used for this broadcast have special filters on them, and those protect the operator's equipment and also the operators themselves, because if you view the eclipse without the proper protection, then it can severely damage your eyes.
Yeah, that's right. We want everyone to enjoy the eclipse today, but we want them to do it safely.
Right. So how do you do that safely? Well, you should be shielding your eyes with eclipse glasses like these. Hopefully you bought them from a reputable source and that they have a special rating on them, and this rating means that the lenses meet international standards to protect your eyes from the sun's bright light. But Sarah, you can remove the glasses during totality,
That's
correct?
right. If you're lucky to be in the path of totality, you can, for those, that short amount of time that you're in 100% totality. 99% totality doesn't cut it.
Right, exactly. 100%, nothing less. Now, if you don't have eclipse glasses, you can enjoy it indirectly with tools like pinhole projectors. And if you want to make one with us live in about 30 minutes, just grab a sturdy piece of paper or cardboard and a thumbtack or other sharp pin. I'm going to use my NASA pin for when we make it. All right, so Sarah, what are we expecting today? What is a total solar eclipse?
So total solar eclipse happens when the Earth, the moon, and the sun are so perfectly aligned that the moon completely blacks out our view of the sun.
And does that happen often?
Actually, somewhere in the world, there's an eclipse about every 18 months or so, but like in any particular place, it's a pretty rare event.
Yeah, I mean, specifically here in Cleveland, the last time Cleveland had a total solar eclipse, get this, 1806.
Wow, that's remarkable.
So quite a long time ago.
Yeah.
Once in a lifetime opportunity. All right, but not everyone is going to be able to see the moon completely eclipsing the sun.
That's right, only those of us in this narrow path of totality, but just about everyone in the U.S. will get to see a partial eclipse today, weather permitting.
Weather permitting, yes. I hope that Cleveland here and everyone else along the path of totality will be good and clear. Okay, so let's take a look at today's path of totality. It passes through parts of Mexico, 15 U.S. states, and southeastern Canada. There's an estimated 32 million people who live along the path, and not to mention the tens and thousands of people who travel to somewhere along it as well, like us. You're from D.C. and I'm from Florida.
And I feel very lucky to be able to get to travel to see this one.
Yeah, absolutely. And we're going to have live reports from our correspondents spread out across the path, all excited to share this event with you. Some recognizable locations in between: the Indianapolis Motor Speedway, home of the famous Indy 500, and then also Niagara Falls, where officials expect up to 1 million visitors. Look at our team there waving at you. Happy to see you guys, and we'll hear from you soon. Okay, so again, we will hear from those correspondents, but also on our broadcast, a live interview with astronauts on board the International Space Station. Sarah's already ready.
So excited
She's ready, because that's going to be obviously a unique place to witness today's celestial event, so we'll talk to them about that. We're also going to explain some of the science NASA will conduct during the eclipse and why that's important to you. And if you have questions about today's cosmic alignment, use the hashtag Eclipse to send those in wherever you're watching us. We already have some questions from some kids.
Excellent.
And a celebrity. I can't wait to surprise you with who that is. All right, in addition to NASA's Eclipse event here, there are plenty more in communities across the country, so why don't we take a look at some of them now. All right, so this is the California Academy of Sciences. That's a beautiful place to witness.
Wow, looks like they have great weather today. They're only going to get a partial eclipse there, but you know, still, that is more than enough reason to get outside and enjoy some time with your friends and family.
Waco, Texas, people have their seats. They're ready to go. They're all comfortable. I see some coolers there.
Oh.
And this is the Adirondack Sky Center. They have a big field for people to view. You know, a couple of days ago, we saw the same field. It was covered in snow.
So I'm glad they have a nice place to sit.
Exactly. And Kennedy Space Center, the famous rocket garden that we have at the visitors complex there, that's also a cool place to watch a partial
eclipse, yep.
Yeah. And then lastly, the Mentor Civic Amphitheater, a nice big field again to take a look out into and enjoy today's event. I'm sure that'll fill up soon.
Yes, I'm sure. Still gathering there.
All right, very much a party atmosphere we've seen in some of those watch parties, and especially here, again, the music, the exhibits, all the things happening here. Kind of reminds me of a sporting event, you know? So because of that, I'm going to ask you, who's the GOAT today, right? Is it the moon, is it the sun, or is it the Earth?
I mean, I'm a lunar scientist, so I may be a little biased, but you got to go with the moon on this one, right? It's the moon that is like coming in for the block today. It's all the action to the moon.
I love that sports reference, but I'm going to have to say Earth. Because, well, first of all, we love our home planet, right? But because we're here, the moon has something to project its shadow on, and that's why we have the celestial alignment and show we're about to see today. That's where I'm going. That's how I'm going, yeah? All right, and now we want to know which team you're on. You can cast your vote by going to @NASA Solar System on Facebook, X, or Instagram, and we'll reveal the winning team at the end of the broadcast. Earth. The moon shadow will only be over land for about an hour and 28 minutes today, moving at an average speed of about 1,900 miles an hour. Keeping track of it for us is NASA's James Traley.
Yeah, thanks so much, Megan. I'm going to have to go with option number 3 there, the sun, because it gives us the energy for us to thrive here on Earth. And speaking of energy, it is bustling here at the Kennedy Space Center Visitor Complex. I'm coming to you from our new Gateway exhibit, where we today only have a partial eclipse, but still super excited to be tracking all of today's events live with our Eclipse Explorer. This right here is a fantastic tool that was developed by our friends at NASA Goddard Science Visualization Studio. They put this tool together for us to track the eclipse down to the exact second. If you wanted to get an access to this yourself, get a feel for how this is going to look in your neck of the woods, you can go to go.nasa.gov/Eclipse Explorer, and you can track where your city is going to be, your zip code, by punching it into this little box here. It's going to snap right to your location and give you some key stats. You just saw Cleveland there, so I can bring them up here. Cleveland is expecting peak totality here to start at 3:13:45 to be precise, local time. They've got a time of totality of 3 minutes, 49 seconds, plenty of time to really sit back and bask in their moment in the fully eclipsed sun. I'm going to be tracking all of this all throughout the afternoon for you to make sure that you do not miss a second of this coverage. Even if you're outside of that path of totality like we are right here, more than 99% of the U.S. is going to be able to see at least a partial eclipse. Some places are already experiencing, you just saw that footage from Mazatlan a little while ago, they are already experiencing a partial eclipse. And as always, if you are in partial, be sure to wear proper eye protection to protect your vision so you can safely enjoy today's fantastic celestial event. Plenty of awesome stuff coming up. We're going to keep a keen eye on that weather. Cleveland's looking nice and beautiful, very clear skies. Megan, back to you.
Thank you, James. And joining us now is Dr. Bob Lehman, a heliophysicist at NASA's Goddard Space Flight Center.
Thank you.
It's great to have you here.
Thank you very much.
So talk to us. Today's total solar eclipse, it's going to look very different from what we saw 7 years ago, right?
It is, right. The sun is going to look, the solar corona is going to look very cool today. It's going to look cooler than it did last time. And I mean cool in the sense of wow.
Not cold.
Not cold, because the solar corona is like 1,000,000 degrees. But compared to last time, was close to the solar minimum, the minimum amount of magnetic activity on the sun. There's this 11-year or so cycle, and 2017 was closer to minimum, and 2024, April 2024 was pretty much close right to the maximum of that. So we're going to see the maximum amount of dynamism of activity, and it's going to look, you'll see rays shooting out.
And does that increased activity mean that we have a chance for new discoveries today and increased science?
Sure. So in addition to the science that will be done because of the eclipse, just greater activity levels means that we have more chance to see what the sun is going to do, increased radiation levels, increased activity eruptions that will affect the Earth.
So how does that affect the Earth, and how do we study those effects? What do we have, the tools, the assets to study those effects?
Sure. So we call the whole general thing space weather, so we get increased radiation or what we call coronal mass ejections, chunks of the suns that blow off and hit the Earth. And those affect things like power grids and radio communications and GPS satellites, all of which are everyday real implications for that thing that's 93 million miles away.
And how do you feel? You're a heliophysicist. This is kind of like your Super Bowl.
Pretty much, yeah. You are not the first person to say that to me today.
and are we right?
Pretty much, yes. I mean, this is it. I mean, 7 years, and I like to say there's the diving, trying to reach the goal line from the Super Bowl, 15, 20 years ago, that was like, totality, not totality, and yeah, today is it. I'm really looking forward to it.
Yeah, absolutely.
And we will have a whole bunch of fun here.
Yeah, again, eclipses are a unique opportunity to really study the sun and how it affects us. So I know that, again, your fellow heliophysicists and really across the disciplines of science, I know that today is really special for a lot of people.
It is, yes.
Thank you, Bob. I really appreciate you being here.
Thank you so much.
All right, it's time now to check in with our first team along the path of totality. Here is Tahira Allen in Kerrville, Texas, a city so lucky it gets a solar eclipse twice in a single year.
Thanks, Megan, and welcome to Kerrville, Texas. I'm Tahira Allen with NASA Communications.
And I'm Gina DiBraccio, the Deputy Director of Heliophysics at NASA Goddard.
We're live from the Kerrville Eclipse Festival, where tens of thousands are gathering to witness the second solar eclipse that has passed through this town in just 6 months. Now, this is incredibly rare, and people have traveled from all over the world to share in this spectacular moment right here at the crossroads of the eclipse. Now, Gina, we were lucky enough to be here last year for the annular solar eclipse. How does it feel to be back?
The annular was such a spectacular experience, but I'm already feeling even more energy today, and
it's
I'm
like
so
double
excited
the crowd.
to be here. It is. Yeah.
No, and we have a full day of celebration in store. The town really turned out for this event. This morning we heard from the mayor, and we are surrounded with food and shopping and different activities. I think I saw the Texas State Astronomy Club here giving out free telescope viewings. So it's just a really, really special moment for people to come together and enjoy this celestial event.
It's right to hear it. And we had some cloud coverage today. It's looking to be pretty good.
It's going back and forth. So fingers crossed.
Regardless of how this turns out, we have live music and dancing afterwards, so it's going to be a good day.
Absolutely, and this is going to be my first total solar eclipse, and so last year was incredible with the annular. Folks, if this is your first total solar eclipse, let us know in the comments wherever you're watching. We'd love to hear it. So this is also a good time to remind everyone that it is not safe to look directly at the sun without specialized eye protection for solar viewing. Now that is except during the brief phase where the moon is completely covering the sun, and that will only be for those in the path of totality. Now we have a special guest that you might recognize popping in to share some important tips to make sure you stay safe during today's events.
Hi, Eclipse enthusiasts. Lance Bass here, and I want to tell you how to protect those eyes and stay safe during a solar eclipse. During these celestial events, the sun, earth, and moon are in sync, creating solar eclipses. You can look directly at the sun during a total solar eclipse, but only when it's completely covered by the moon for a brief period known as totality. This is a really special moment. At all other times, you should wear eclipse glasses so that you don't say bye-bye-bye to your vision. Seriously. And eclipse glasses are not the same as regular sunglasses. No, they're not. Safe solar viewers are thousands of times darker and will have a specific certification that you should look for right here. Don't be a space cowboy and try to look directly at the sun. If you don't have eclipse glasses, you can use an indirect viewing method, like a pinhole projector. You can make one of these with something as simple as an index card with a hole, or a colander, or even your hands. With the sun at your back, you can safely project an image of the sun through the hole onto a nearby surface, like the ground. It's gonna be me who is wearing my eclipse glasses, and so are you.
Now, you can't have an eclipse without the sun, the moon, and the earth. And as you heard from Megan and Sarah earlier, we've been hosting a friendly competition to see which one of these three teams that you're siding with today. Now, Gina, I feel like it almost goes unsaid here, but I have to ask, I don't want to assume, which team are you repping today?
You probably were going to guess sun.
Oh,
Team Sun.
Who would have thought?
You're right.
No.
So heliophysics, it's the study of the sun and its influence on everything. And it impacts all of our planets. And today, the solar corona is stealing the spotlight of the show. So Team Sun for me.
I guess it really is the star of the show today. But you know what, Gina? I think I'm going to have to be a little bit biased too.
Okay.
So International Observe the Moon Night, which is NASA's annual celebration of all things moon, actually falls on my birthday this year.
Okay.
So I think I'm having a little bit of a lunar connection.
All right, Team
But
Moon.
for those watching, if you haven't joined the fun yet, you can vote for your Eclipse team on NASA's Solar System Facebook, X, and Instagram. We're going to be sharing those poll results throughout the show, so be sure to go vote for your team. Now, also during the broadcast, you can send us questions using hashtag Eclipse on social media. We have teams standing by online to answer, and we're going to be taking some of those questions live on today's show. Now, speaking about taking questions live, Gina, we actually had some kids send in videos before today's show.
Oh, nice.
So let's roll one of those right now.
My name is Jonathan. My question is, will NASA do any experiments during the solar eclipse? Thank you.
Oh, great question, Jonathan. Now, we have a bunch of different experiments that will take place during the eclipse today. So first, we're trying to study the solar corona. So we have NASA's WB-57 high-altitude research jet flying across the path of totality, taking pictures of that upper atmosphere of the sun, that corona, so that we can learn its composition, why it gets to be heated to extreme temperatures. But we also care about the eclipse's impact on Earth and the upper atmosphere. So we're launching 3 sounding rockets up into the atmosphere before, during, and after peak eclipse so that we can study how the atmosphere is changing as well.
So, you know, we're studying it with a plane, we're studying it with rockets.
Exactly.
Any other way?
You know, we have balloons, science balloons that are going up too, and we also have different ways that the public will be able to get involved in some of these experiments too.
Thanks, Gina. And I actually have a great follow-up question to this. This is from Lisa on Facebook, who wants to know more about the sounding rockets. So they asked, why is NASA shooting rockets into the moon's shadow during today's events?
Okay, let's talk more about the sounding rockets because they are a lot of fun. So the first sounding rocket will be 45 minutes before peak eclipse, the next one during that peak eclipse, and the final one after, 45 minutes after. And that's because we really want to understand the difference in density and temperature and these different factors in the upper atmosphere and really get a sense of how the atmosphere changes as the eclipse is coming and passes over. So we have all these rockets going up and it'll be a good day for that.
Great, and hopefully we'll get to see a replay of that later on in today's show.
That's right.
Now, folks, it is really special for us to be back here in Kerrville, Texas, covering today's total solar eclipse. Just last October, an annular solar eclipse passed right through this town. Now, for a location to be at the crossroads of these two incredible celestial events is rare. Let's take a look at how the community has been preparing in the lead up to this big day.
Kerrville is the eclipse capital of the state of Texas. It is known as being the capital of the Texas Hill Country. It's the epitome of Texas. Ranches, deer, beautiful streams like the Guadalupe here. Kerrville is very welcoming.
It's a wonderful community.
Tight-knit, small.
It has about 25,000 people.
Kerrville is blessed to be in that special square, the annular eclipse in 2023 and the total solar eclipse in 2024.
We're talking about crossroads, you know, we get it twice.
Two eclipses right here, right where I stand. It's statistically extraordinary.
We get 2? in less than 6 months.
Everybody's excited about it. City council, county commissioners, everybody's working diligently to be able to provide safe opportunity for the influx of people.
This will be the biggest event in the history of the city, and that's why the city is preparing. We're preparing to make the event enjoyable for everybody who wants to see this tremendous natural phenomenon.
I think that Kerrville has done an awesome job of preparing, way in advance.
It's getting that message out to people to make sure that they're taken care of personally, but then there's the science part of it, letting them know what is an eclipse.
And I'm just having a great time going out and talking to civic organizations and clubs and to talk about eclipses. So this will be my 4th and 5th solar eclipses.
I've seen total eclipse in Nebraska. I drove 1,200 miles for a little over 2 minutes, and it was well worth it.
And just couldn't believe the experience of the eclipse. I mean, it literally gives me goosebumps every time I talk about it. It's a visceral, emotional experience that is just, you have to experience it to understand.
I thought I knew what it would be like, but I gasped at the sheer wonder.
It's going to be a, you're going to hear that intake of air and awe.
It was the most beautiful natural thing I've ever seen. So to have an eclipse basically in my backyard is just, it's indescribable.
We're here now with Catherine Troach, a telescope operator with the Night Sky Network, who is giving us these high-definition views of the sun that you see in your screen right now, of the eclipse over Kerrville, Texas. Kat, thank you so much for being here with us.
Thank you so much for having me, and let's thank the weather for cooperating finally.
Right? Oh my goodness.
Thanks, Kat. And so I'm looking at the telescope feed that we have, and we have first contact now here in Kerrville.
Yes.
Okay, so for people who want to become an amateur astronomer, what advice do you have? Where should they get started?
The easiest way to get started is to look up Night Sky Network. Night Sky Network has over 400 astronomy clubs in the United States. You would just use our search function to plug in your city and find the club that's closest to you. And if you don't have a club that's close to you, you can use our coordinator tips to start your own astronomy club.
Wow, that is awesome. And you know what? For folks, if you want some more details on the Night Sky Network and other things on how to become an amateur astronomer, you can visit go.nasa.gov/Night Sky Network. Now, a fun fact about today's broadcast that I absolutely loved learning was that so many of our telescope views that you're going to be seeing today are from amateur astronomers. And so, Kat, again, on this topic of, sky gazing, I heard that those in the path of totality might be able to witness more than just a total solar eclipse today. Could you give us a sneak peek on what we could expect?
Absolutely. So if we have clear skies in the path of totality, as it gets darker, you'll start to see 2 bright points of light. That would be Jupiter and Venus. And then as we get to totality, you'll be able to see the fainter planets, Saturn, Mercury, and Mars. And if you're lucky, you'll be able to catch Comet 12P.
Oh, what a crazy, cosmic alignment today, So, man.
Great. So for the amateur astronomers that actually want to view today's celestial event, what tips do you have for them?
So, of course, you need to have solar protection. You need to have solar-safe glasses. And you need to have solar filters for your telescopes, your binoculars, your cameras. But you can also use indirect viewing, like a pinhole projector box, or you can use a disco ball.
A disco ball?
Yes.
Wait, how does this work? Can you, walk us through this?
So as the sun hits the mirrors, and it'll cast a little reflection onto the surface here, you'll see little crescent shapes as the eclipse progresses.
That is incredible.
We need to keep that disco ball.
Oh, yeah.
Right? No, seriously. So, Gina, didn't you say you could also use your hands
That's
at one
right.
point?
You can take your fingers and weave them together to let the light project through so that you can see the projection of the eclipse on the ground.
Absolutely.
There.
That's fantastic. So a lot of different ways to be able to view today's event.
There's no one wrong way to do it, unless you're
just
using
to do it.
Just do it. Just make sure you do it safely.
Yeah. And so, Kat, too, earlier you gave me a little reveal of your shirt, and it is too perfect for today's show. Could you give our viewers a little taste?
Sure, no problem. So if you know, you know.
If you know, you know. Totality going on at the moment.
Love it.
Thank you so much for being here, Kat.
Thank you again for having me.
Absolutely. And so now coming up soon, we're going to get our first views of the total solar eclipse as it begins in Mexico, sweeping across North America. We have correspondents all along this path who are going to bring you live into the action as it happens. First up, let's check in with Joy Ung in Dallas, Texas.
Thanks to Harry and Gina. So welcome to the Dallas Arboretum and Botanical Garden. I'm Joy Ung, and as you can see behind me, we have a lot of people eagerly waiting for the total solar eclipse. It's so amazing to hear so many people talk about the sun and the moon, and what makes this day even special is that the eclipse gives scientists a really unique chance to do science. So to tell me more, I'm here with NASA scientist Dr. Ashley Greeley. Thank you so much for joining us.
Hi Joy, thanks for having me.
So firstly, how are you feeling about today?
I'm feeling really excited. The skies are starting to clear out and it looks like we might get a pretty good show.
Fingers crossed. So earlier in the show, we learned that today's eclipse will look quite different from the 2017 eclipse. We're going to see more structures in the sun's outer atmosphere. So Ashley, can you tell me, why is that different? Why is the sun going to look different, and why is it changing?
Sure. The sun goes through phases, which we call a solar cycle, that last roughly 11 years. And those are periods where the sun is less active and periods where the sun is more active. We're entering a time of solar maximum, which is really exciting because that means that the sun is more active. Its magnetic fields are more dynamic. We may see features here, such as streamers, which looks like little spiky wisps in the sun's atmosphere, which we call the corona, and then little prominences, which look like little pink arcs on the surface of the sun. Yeah, we're really excited to see this, and we hope that we'll see some really interesting features. There may be a little bit of asymmetry as well in the magnetic fields, and I don't know, I guess we'll have to find out in about an hour.
So the sun is changing. So do those changes affect life on Earth at all?
Sure, yes. The sun does affect life here on Earth. We have a term that we call space weather, which applies to the field of study of everything from the sun to the Earth and in between, and how that affects life here. We are fortunate that on Earth we are protected from things coming from the sun by our magnetic fields, which shield us from those explosions that come from the surface of the sun that we talked about. Those can result in really fun occurrences, such as the aurora. There can be some negative side effects, but those are mostly limited to things that are outside our magnetic fields. The storms from the sun can interfere with satellites, and it's something we really have to think about as scientists as we start to plan for putting humans on the surface of the moon or potentially sending them to Mars. Those energetic particles that result from the sun can impact humans, so that's just something that we have to learn about and take into account.
So the sun is always there, of course, but why are eclipses a good time to study these effects called space weather?
Yeah, eclipses are a really cool time for scientists to be able to study the sun. It's really hard to completely cover the disk of the sun in order to study the sun's atmosphere, especially that inner part of the atmosphere. We're really fortunate that here on Earth, our moon is just the right size and just the right distance from Earth that it can completely block out the sun's disk during total solar eclipses. So we're really able to observe that inner atmosphere in a way that we can't normally. So this event is really exciting for both scientists and the public alike, and that's just such a cool experience to share together.
Thank you so much, Ashley. So if you're lucky enough to be in the path of totality, keep an eye out for that sun's outer atmosphere, the corona, and you'll know that you see these spiky features, and it's because the sun is heading towards its most active phase. So for now, let's head to our friends in Russellville, Arkansas. Jasmine, how are things looking on your side?
Joy, things are looking absolutely fabulous in a very sunny downtown Russellville, Arkansas. As she said, I'm NASA's Jasmine Hopkins, and I'm coming to you live from the Depot District, where the city is throwing a massive block party, all in celebration of the total solar eclipse. Now, people in Arkansas have great reason to celebrate because this is only the second total solar eclipse visible from the state since it was first established in 1836, and the next one visible from here won't happen for another 2 decades. So people around me are gearing up for what feels like a once-in-a-lifetime opportunity. Now, it's not just the residents of Russellville that are excited. On average, the city has about 29,000 residents, but for the past 8 months, they've been preparing to receive upwards of 100,000 tourists right here in the city. Now, of course, NASA has been a big part of that preparation, so to show you what we've been doing to help, I have a video here to show you. So we have been talking to the next generation of space explorers right here in Arkansas. We started off at Arkansas Technical University, and then we moved on to Russellville City Schools, where we spoke to hundreds of students all the way from 8th grade to 12th grade about this total solar eclipse. We had NASA's Marshall Space Flight Center, the Arkansas Air National Guard, the U.S. Space and Rocket Center, and even the Paris Observatory joining us all the way from France. Now, during that moment of totality, Arkansas will experience from 94 to 100% obscurity from the sun, and we'll have 4 minutes and 12 seconds to really soak in that fantastic cosmic event. Now, until that moment, of course, we are telling the residents to stay safe, keep those solar eclipse glasses on. But now let's go from Arkansas to Illinois with Blair Allen. How are things looking for you?
Jasmine, we're super excited here because crowds are filing into the stadium, but the main story here is the weather. Everything looks absolutely good and clear for totality today. We're very excited. We're just hoping, just like 2017, a little cloud doesn't come in and obscure things. But I tell you what, there's been a total solar eclipse here in 2017. Observation did not stop at SIU. Joining us now are 2 SIU students who actually did some observing. This is Callie and Paige. Now, Callie, I know that you guys went to Australia in 2023 and you observed the totality using an interesting technique. Can you tell us about that?
Yeah, so when we were in Australia, we used a sun funnel to view it, and what it does is it projects basically what the telescope is seeing onto a film. And so a sun funnel is just basically a funnel with 2 hose clamps and rear projection film, and it just projects the sun, and we actually captured a picture of totality as that eclipse was happening.
And it's pretty cool because it allows other people, instead of having to go through the eyepiece, you get to see it. Pretty impressive. Now, Paige, you guys are going to do some observation today. What are you set up for here in Carbondale today?
Yes, so we have 2 telescopes set up with the sun funnels for viewing for a select view of the public, and right now we're pointed at the sun and we're excited to see totality.
Now, what are your odds on good weather?
It's looking pretty good. I'm excited.
Isn't that great? I'm so excited. I tell you what, one final question, because I know you're experts with solar safety, but Team Earth, Sun, or Moon?
We're both Team Moon.
Team Moon, Team Sun. I tell you, that's the best you're going to get, but we're all pro eclipse. Back to you, Tahira.
Let's go Team Moon. So, as you can see, folks, we've got a lot of exciting things in store all across this country, and that was only half of it. You're going to meet three more of our locations later on in the show. Now, Gina, we've got a ton of questions coming in online right now from our viewers.
Yep.
How do you feel about some Q&A?
Let's answer some.
Okay, perfect. Let's do it. So our first question is from Fair Cerritos on Instagram, who wants to know, how can I help NASA?
You can help NASA by participating in the eclipse. If you can see it today, go outside, enjoy the moment, or download the Globe Observer app. You can do that right now before the eclipse crosses your path. You need a thermometer, and you just record the local temperatures and the cloud coverage.
Fantastic. Globe Observer app. So thank you so much, Gina, and thank you to everybody sending in those questions. We'll take some more later on throughout the show. For now, let's check back in with Megan and Sarah in Cleveland, who are standing by with an out-of-this-world surprise.
Yes, quite literally that, Tahira, because we have a special treat for our viewers right now, joining us live in space, 250 miles above the Earth in the International Space Station. Everyone, please help us welcome NASA astronauts Jeanette Epps and Mike Barrett. Sarah, you've been waiting.
I'm so excited.
For this.
Oh, there they are.
Hello, everyone. Oh, Jeanette, Mike, thank you for joining us.
It's a pleasure to join you guys, and I hope everybody appreciates NASA scheduling this eclipse to bring the world together.
Yes, thank you so much to NASA, and thank you so much for joining us. Now you guys will have 3 opportunities to view the moon's shadow over North America, and that last pass will give you guys the best views. And we hope to also share those live views with everyone here on this broadcast around 3:30 p.m. Eastern Time. Now, Jeanette, I have 2 questions for you. Are you looking forward to being one of the few people seeing today's total solar eclipse from space? And 2, I know your crew member Matt Dominic will use a camera with a solar filter to photograph the sun being eclipsed by the moon. Will you also be taking photos of the celestial alignment?
I'm definitely taking pictures of the solar alignment. And I think we're very fortunate to be here at this special vantage point to see such a special event at this time. So I'm definitely excited.
What about you, Mike? What's going through your mind as you're preparing to see such an awe-inspiring event?
Well, admittedly, I'm a bit of an eclipse junkie. My first one was like when I was 19 with the homemade telescope in the desert, and a few since then, and actually during the 2017 eclipse, I was on a chartered aircraft several hundred miles off the coast of Oregon watching it, and I got a strange bucket list, and this is one of the things that's on it, to actually watch an eclipse shadow cross the Earth from space. So I'm ecstatic to see this box gets checked and just to see this amazing thing from up here.
Yeah, the fact that that was actually a box on your list is pretty
That's
amazing.
amazing.
And then now it's getting checked. So, you know, for those wondering, this is what the moon's shadow will look like to Jeanette and Mike. We're going to show you video taken from the space station of the total solar eclipse in 2017. And you can clearly see the shadow moving across the top of your screen there from left to right. We actually sped up the video so you can see more of that transit. This would look a lot slower to them, but really cool. Jeanette, eclipses give us a unique opportunity to study the sun and how it affects the Earth. Can you tell us about the atmospheric waves experiment attached to the outside of the space station right now?
Sure. We have an atmospheric wave experiment that's going on now, and what it looks at are these atmospheric gravity waves. And these waves transport energy and momentum up through the climate system. So with the imager on the atomic wave experiment, we're going to look at how these atmospheric gravity waves impact our Earth's climate, how it can impact our space and global and all of our comms, how it can affect our navigation system. And so over the next 2 years, researchers will use an infrared imager to look at the global distribution of these waves as well as their characteristics.
Mike, how does it feel to have a hand in maintaining the space station so that important science like the atmospheric waves experiment can happen?
Well, of course, the main reason we're up here is actually to conduct that science. We maintain the station to keep this platform what it should be, what it was built to be, which is a vibrant laboratory, which covers so many different disciplines on the inside and the outside, like the gravity waves experiment. I mean, it's an honor and a privilege, as much as anything, to have a hand in that science, and we end up being basically the eyes, the hands, the on-site presence to conduct that science. And we get to be the first to see results of just amazing things that are years in the making by a bunch of really smart, ambitious scientific teams on the ground. So that's really where the joy is. Maintaining the station is just like maintaining a research ship, something I actually quite like. So I feel very much at home in that role.
It's still blowing my mind. I mean, we're here in Cleveland, Ohio, live. You guys are up in space in the International Space Station. I can't believe the opportunity that has been afforded to us, and I hope our viewers really enjoyed this time with you. And I hope you enjoy the show from up there. All right.
We have, but we do want to close by saying, first of all, we really enjoy being here, but everybody stay safe. And use the simple means to protect your eyes as you look at the eclipse, as Jeanette and I are modeling here, which makes us blind as a bat on the inside, but solar protected on the outside. So we encourage everyone to do the same.
Really great advice from both of them. Thank you so much. Sarah and I have our glasses,
right.
and we're ready to go. Also blind if we don't do this. All right, again, Jeanette, Mike, thank you so much. And we actually have some time to take questions from the audience. We have #Eclipse. That's how you can send questions to us. So let us take a video from another curious kid we have watching.
Hi, my name is Adrian. My question is, why will we not see a total eclipse in California? Thank you.
That's a great question, Adrian. So we only a precious few today are going to get to see a total eclipse because the moon is so much smaller than the Earth. It only casts a very narrow shadow. But still, even in California, you're going to get to see a partial eclipse, and that is still a really cool event. So I do encourage you to get out there and see it for yourself today.
Yeah, absolutely. So again, #Eclipse. Wherever you're watching us, drop that in the comments, and we'll try to get to as many questions as we can on the show. Okay, so we have, obviously, people celebrating with us online and at events across the country. So why don't we check out some of those events again now? Waco, Texas again. People look very, very comfortable in their camping chairs and spread out on picnic blankets.
They look like they're having a good time.
Yeah.
Few clouds.
A few clouds, but again, they have some time there before. Kennedy Space Center, they will see a partial eclipse. We have some people walking around the Rocket Garden.
Oh, it looks like they have beautiful weather there.
California Academy of Sciences, yes, they do. They have clear skies. We're very, very jealous over here. And then the Mentor Civic Amphitheater that's starting to
fill up.
Exactly. There were fewer people when we checked in ago, but now lots of people there and lots of people at the Adirondack Sky Center. I wish I could wave and say hello.
They look like they're getting ready for some stuff, though.
Yeah, absolutely.
They got a
Again, the
little time to
snow
wait.
cleared out because
Yeah.
there was snow over the weekend, but now it looks like a beautiful, probably still crisp day there for them. Okay, and now we're back here with astronaut Steve Bone, who's looking around, taking in the sights, Steve.
I am.
see.
It's just an amazing amount of people. It's really cool to see.
Yeah,
it's really-
absolutely.
you can feel the energy.
And it's really
beautiful.
cool that you're here. So Steve is here because, you know, obviously, as we've been saying throughout the show, you really should have these glasses to safely view the eclipse. But if you don't have glasses, that's why Steve is here. So Steve, I see that you brought some supplies for us.
I did, and I have a little bit for everybody, and we'll see how we can do here today.
All right.
So this is like a pinhole viewer, and so it's basically a pinhole camera. I don't know if you ever had to do that when you were a kid, is make a little camera by basically poking a hole in a piece of paper.
Okay.
And then using that to focus onto a screen.
Okay.
And so we all have pins here, I guess.
Yes. So we have a paper plate, we
Yeah, your
have
Eclipse pin.
index card, and we have pins.
And I have my Crew 6 pin.
Nice, nice. All right, so what do we do, Steve?
Basically, all you have to do is poke a hole in the cardboard.
Okay.
And the sides of the hole will determine the focal length, the focal distance of your viewer. And it
Okay.
has to be big enough that the light will come through. And it's sometimes hard to do if we don't have like direct sunlight. So you want to make sure you have a big enough hole. I think
Okay.
that'd probably be enough.
Yeah.
And then what you'll end up doing, if we had the sun, you could basically over your shoulder, don't look at the sun.
Mm-hmm. Sun behind us.
Sun behind us.
Yes.
And so you hold this up, and you'll see, you can actually get, there it is. I can see.
We do see it with the lights, the studio lights.
You only need a little bit, and then depending on how far in and out you move it, and the sides of the hole, that gives you your focal length.
Got it.
Just like a lens.
And basically, like we're saying with the studio lights, if something were to pass over the studio lights, that same shadow essentially would be projected through
Absolutely.
the index card right now. That's how you safely watch it.
That is a good, safe way to watch it. There's a lot of other ways to see it as well.
I know
And,
that.
Oh.
I have that.
Come prepared.
Colander, right?
Yeah. So that's a lot of fun because if you're in an open area like this today, and you don't have your glasses or you just want to see something really cool, again, put it over your shoulder and hold it, and you'll get a big array of all those little eclipses happening on the ground below you.
Yeah, actually, I think we have a picture of that. I'd love to see that because really it is
Yeah, it's
a very,
pretty.
perfect. Look at
Yeah.
that, Steve.
Oh, yeah.
Well, I mean, even if you don't have anything, right, you can
Yeah.
actually use your hands to make your own sort of improvised pinhole camera.
Absolutely. That's amazing. And, you know, I was explaining a little bit ago that in my own yard during the annular eclipse, when I was out working in the yard, and I said, hey, there's an annular eclipse going on. So I went under a tree, and I was looking at a tree, and then on my driveway, all these little eclipses,
Oh,
just
that's
hundreds of them.
amazing, yeah.
And it's
Beautiful.
absolutely amazing pictures.
Great. So I hope if
So-
people have trees near them, they can take a look at that. Steve, thank you so much
You're
for
very
being
welcome.
here. We really appreciate
Have
it.
a great day.
All right, so the eclipse is getting closer and closer to the west coast of Mexico. We will experience totality there at Mazatlan, in particular, 2:07 p.m. Eastern Time. So let's head back over to James at our eclipse board for another look at the path of totality.
Yeah, thanks so much, Megan. A lot coming up very soon, and make sure you know exactly when to go outside to observe that totality if you're on our path, or even right now, if you're experiencing a partial eclipse. I've got in our Eclipse Explorer here, I can zoom out just a hair here to show you this. I've got our penumbra on, so this is all the places inside here already experiencing a partial eclipse. You've been seeing some great feeds from our camera in Mazatlan, Mexico. They've been experiencing that kind of crescent sun for a little while now. They're just about 20 minutes out from actually experiencing totality itself. They're going to have a long window where they are 4 minutes and 17 seconds. For some context, back in 2017, the last eclipse that swept across America, the longest time was only around 2 minutes and 40 seconds. That was in Carbondale. This time around, some very long times, just a little bit northwest of Torreon, Mexico. They're going to get upwards of 4.5 minutes. A lot of time to really observe it, but just make sure that you know when to be outside. And as always, access that tool at go.nasa.gov eclipse explorer. This is going to keep moving on. You see this little thing. I have this actually running in real time. This is our shadow of totality. This is going to continue to move further and further to the northeast and actually make landfall in just a few moments in Mazatlan, Mexico. As you've seen all throughout the broadcast, we've got correspondents all up and down the U.S., all the way up to Maine, covering this live. Very excited to continue tracking this. Make sure you know what's going on here. But for now, back to you, Megan.
All right, thank you, James. So now let's introduce you to more of our correspondents along the path, starting first with NASA's Lauren Ward, standing by to show us what's happening in Indianapolis, Indiana.
That's right. Thanks, Megan. We are at the Indianapolis Motor Speedway in Indianapolis, Indiana. It is a gorgeous day. Behind me, I have over 50,000 people here to spectate today. Today, we are waiting for a spectacle that is of a celestial kind. Of course, this is most known for the Indy 500, but we are waiting for something a little bit special today. With me, I have the 2016 Indianapolis Motor Speedway winner, Alexander Rossi. Good to see you.
Good to see you. Thank you so much for having me.
It's great to have you. So the Helio Big Year is a celebration of sun science and how the sun touches everything, including IMS. So tell me, the track when you're doing a qualifying round is about 4 minutes long, which coincidentally is the length of totality. So tell us, what is it like being on the track?
You know what? The sun plays a huge role in determining the performance of the car based on the track conditions. So we actually, when it's a day like this, as much as it's beautiful for the fans, it's actually very difficult for us as drivers, because as the surface heats up, the oils come to the top of the asphalt and it actually becomes slippier. So that's surprising to people. They think that temperature would mean grip, but it is until a certain point. And then once it kind of crosses over 100 degrees on the surface, you start to actually go the other way.
Wow. And tell me about those tires. How does the sun affect those?
So we use slick tires. So Firestone tires are slick. On a road car, you have tread, right? Because they're supposed to use in all conditions. Slick tires actually have a bigger contact patch, more surface area, so they generate more grip at a temperature, right? So they operate between 180 to 230 degrees Fahrenheit. Again, the sun is good until a point. When they go over that 230 degree mark, you start to lose that grip again.
Ooh, all right. Well, we have a little competition going on today. We're trying to determine whose big day is it. Is it the sun's, the moon's, or the Earth? So my question to you is, are you Team Sun, Team Moon, or Team Earth?
That's a hard one, but I'm going to go Team Earth. You know, I just think we're so lucky, especially today with the people that are around us here, to be able to witness what we're about to see. Go Earth.
Go Earth. You heard it here first. All right, guys, thanks. We'll be back here. Daryl in Niagara, over to you.
All right, thank you very much, Lauren. Just 500 miles northeast of you, we are here at Niagara Falls, right next to the Niagara River. This is a special location for a lot of people because it is a once-in-a-lifetime opportunity to see a natural wonder set against a celestial one, the solar eclipse. And so let's talk first of all about the natural wonder, and it all starts right here. Look at this massive river and the amount of water that's moving through here. 500,000 gallons of water, 500,000 bathtubs actually going over the falls at every 60 seconds. It's tremendous, the flow here. It interacts with the air, it hits the rocks, and it also, you know, it flows up a mist column that is omnipresent. This is always here. So one of the things that eclipse watchers want to see is, how does it interact with the light? Will we have a pink rainbow because only prominences from the sun will be seen and they're pink? We'll have to see about that. One thing we do need is a little bit better cloud clearing around here, because we do have some cloud cover. But that's okay. People who have gathered here are excited and they're hopeful that it will clear. Who's here? Well, I want to show you our camera from about 500 feet away. Look at all my friendly eclipse watchers. Are you guys ready for an eclipse? Yeah! Well, I love the energy. We could use this energy to blow the clouds out of here. As our camera backs out, you're looking at Terrapin Point, and this is the lawn here. It's roughly the size of a football field, and everybody who's here, a lot of people came in at 6 a.m. this morning. They currently cut off the park from anybody from coming further into Goat Island here. So this is the max capacity that we're at right now. It's that popular. Over to the other side, our friends from Canada. Look across the river gorge, about 1,000 feet away. Niagara Parkway is lined with people. So it's a beautiful shot over there, and we really appreciate our Canadian friends who have joined us. Now, this is our Canadian friends who have joined us. Now, this isn't just about the solar eclipse. We've been here for the past week, and we were at locations all across Niagara Falls, 12 to be exact. Take a look at this video. Crowds of people packed the Niagara State Park Welcome Center, where Commander Munikin Campos, the mannequin who flew around the moon during the Artemis 1 test flight in 2022, was on display. Our partners at the Canadian Space Agency sent kids virtually to space all week long. And NASA experts from the Kennedy Space Center gave presentations and talks at places like the Niagara Aerospace Museum and libraries across the area. The outreach was a huge success, with thousands of people participating in the events and passing through our exhibits. And we just want to thank everyone who came out to see us at all our locations, and we hope you left a little inspired about space exploration and a little wiser about all NASA's missions. Okay, coming up, we've got a very special guest for you who's going to share the eclipse with us, CSA astronaut Jeremy Hansen. He's going around the star today, the moon. Not the star, the sun, the moon, the star of the show, I should say. He's going to be here. He's interacting with the public. We're going to get his thoughts on totality along with everybody else who is here. And we're pumped and excited. Right, everybody? We ready for the eclipse? Can you hear the excitement? All right, now I'm going to send it 800 miles to the northeast to my colleague Angelique Herring, who is in Holton, Maine, where I hear you have some pretty good weather.
Hello, Daryl, and welcome everybody to Maine. That's right, we do have some great weather. We are here in Maine, and actually we're about 3 miles away from the Canadian border, and also about the last stop on I-95 North. So we're the northmost spot for today's eclipse broadcast, at least in the United States. And so hello from way up north. Now, just like Daryl said, we do have some excellent weather here in Maine today. We've been here for a couple of days, and it's actually been pretty wintry right up until about yesterday. We had snow, it was pretty cold, but you know what? Today, the sun is out, the skies are blue, and it's looking like perfect conditions for an eclipse, or as the Mainers would say, wicked good weather. Now, we're actually standing here in Market Square in Maine, and we are outside of the Temple Theater, where it has actually been in operation since 1919. Over the last 150 years of its operation, it's seen everything from silent films to burlesque shows, and today, it's got a more celestial show with the eclipse. Now, the last eclipse to come through Maine was actually in 1963, and that eclipse was only visible for about a minute. In contrast, today's eclipse will be visible for at least just about 3 minutes or so, so everyone here is going to have a lot of time to take in the celestial show, really soak in the event. And the next eclipse won't be coming through Maine until 2079. So it makes a lot of sense that we've got a lot of people here really excited to see this once-in-a-generation opportunity and event. We're all excited. I know everybody here is excited, so we'll be here waiting for the moment that we've all been waiting for, the eclipse. With that, back over to you, Megan.
Hey, thank you, everyone. It was really cool to see everyone along the path of totality. You can tell we're covering a large swath of land because everybody's in different kind of attire. You know, you have short sleeve shirts somewhere, and then you have like Daryl, who it looks very, very cold, and he does have some cloud cover, so I hope that it does kind of clear out for him.
I feel like we've covered all of those levels of weather over the last day and a half.
That's true, here in Cleveland. So, but it's looking nice now, so that's great. And actually, if you were watching our screen here, we just had a view of the eclipse in Mazatlan, Mexico. In about 10 minutes, that's when we'll start seeing totality in that area. And in that time, the U.S.'s top doctor is encouraging everyone to try and watch the celestial event for our physical and mental well-being.
Hi, everyone. I'm U.S. Surgeon General Dr. Vivek Murthy. I'm thrilled to be joining you today as you gather to experience a truly awe-inspiring event, the last chance that we'll have to see a total solar eclipse in the contiguous United States for the next 20 years. The sun is a universal source of light and life. It contributes to our physical, mental, and emotional well-being, and it unites all of us. Today, no matter where you're watching from, whether it's along the path of totality or a partial solar eclipse, you are sharing the experience with millions across the nation. And moments of connectedness like this truly matter. Last year, I issued a Surgeon General's advisory warning about the public health crisis posed by loneliness and isolation. I shared that our connection with one another is a powerful force that can help protect against the damaging physical and mental health impacts of loneliness. What better reason is there to come together with friends and loved ones than to share a once-in-a-generation experience like the solar eclipse? This is an experience that will stay with you, precisely because of the awe that it inspires. Awe allows us to step outside of ourselves, giving us fresh perspective and opening us up to connections. So grab your eclipse glasses and let's enjoy this moment together.
Some great advice. Thank you so much. All right, we have time for other hashtag Eclipse questions. Sarah, are you ready?
I am absolutely ready.
All right, let's take a look at this video from a familiar face.
Hey everyone, I'm Scarlett Johansson and I play a NASA Public Affairs Director in the new film Fly Me to the Moon. I hope everyone is safely enjoying today's eclipse. I actually have a question about the moon for NASA. So during a total solar eclipse, I've heard that craters and features on the moon play a role in what viewers see on Earth when the moon blocks the sun. So why is that?
Question, Scarlett. So yeah, as we, the moon isn't a smooth marble. It actually has big, high mountains and valleys, these craters. And as we approach totality, sometimes you'll hear people talk about Bailey's beads, and these are the last few moments of sun creeping through those deep valleys.
Yeah.
Just before we hit totality.
Yeah. Absolutely. Thank you so much. It's so great to have you here to answer some of these questions, and we plan to take more. If you send them in, hashtag Eclipse again. Okay, if you're just joining us, I'm NASA's Megan Cruz, and this is NASA lunar scientist Sarah Noble. And as you can see, you are watching the official NASA broadcast for today's total solar eclipse. And we are in the heart of downtown Cleveland, where NASA is celebrating this celestial alignment. Take a look at our shot from the air. That is how many people who are just here at the Great Lakes Science Center alone. So many more spread out throughout Cleveland, because again, the last time this city had a total solar eclipse was 1806. But again, just down the road, we have the only NASA center in the path of totality.
When it comes to NASA, I think a lot of people initially think of rocket launches in Cape Canaveral or astronauts floating above the Earth in the International Space Station. But there's a lot of research and engineering and testing that needs to happen before anything can fly. And we have those capabilities: supersonic wind tunnels, microgravity drop towers, vacuum chambers, and a research aircraft hangar. And that's why people from all over the world come to NASA's Glenn Research Center right here in Cleveland, Ohio.
What we work on: power, propulsion, communications. You need it for anything that flies.
We like to say the road to the moon goes through Ohio, and that's because our test facilities are crucial to advancing the Artemis program.
Part of our vision for going back to the moon and establishing a sustainable presence is having a lunar gateway. A lunar space station can fly successfully around the moon and sustain astronauts there. And we are leading the program that's developing the power and propulsion element.
NASA's Neil Armstrong Test Facility in Sandusky, Ohio. It's the only place in the world where you can test a full-size spacecraft for all the extreme conditions of launch and spaceflight.
Right now we have the Orion spacecraft. This is a spacecraft that actually went around the moon, but we're using it as a test article now to make sure that in the launch environment, that spacecraft is safe.
When it comes to aviation, every U.S. plane has NASA Glenn technology on board, which makes your flight cleaner, safer, and quieter.
And looking at solutions like electric and hybrid electric propulsion systems that will reduce or give us different ways of converting energy that are cleaner.
Our center partners with a lot of community organizations to share NASA's discoveries or just get kids excited about science, engineering, technology, and math.
I really enjoyed the VR experience. It was really cool to be able to sit like I was an actual pilot flying. I feel like I could potentially look into considering aerospace.
We've also made it our mission to prepare Cleveland for the April 8th total solar eclipse.
We demonstrated different types of hands-on activities for educators to share with their students, as well as the science behind a total solar eclipse.
My favorite thing about Glenn is our people. Not only are they crazy smart, but they are genuinely good people. And we are literally part of almost everything NASA does. And so what's really great about being here is you're in the heart of it all.
And joining us live is now NASA Administrator Bill Nelson. So great to have you here for this celestial event. Thumbs up. Thumbs up from the Administrator. Now, Administrator, why are solar eclipses so unique, such a unique opportunity to study our sun?
Because you have the alignment of 3 celestial bodies, and unique things happen when that occurs. And it has a profound effect here on Earth. Just think about it. The middle of the day, all of a sudden, it gets totally dark. And us Earthlings are not accustomed to that, and nor are the other little Earthlings.
Right.
All the animals. But it's also an opportunity for us to study much more one of those celestial bodies, and that's our star, our sun, and our star in our solar system. And we can find out more about that gaseous explosion that's coming out from the core of the sun when we can see it better. And we can see it better because we're not looking at the bright ball. You're suddenly looking at that corona, that mass of gases that are coming out from the edge of the sun.
Right.
And you don't have to be a scientist, right, to study this event, right? How do we get help from people across the country to help us study these things?
Well, by asking them. Make a note of anything that you observe and then share that with us.
All right, and Administrator, you know, we have to take precautions when viewing a solar eclipse. Remind everyone what we should be doing today.
Okay, you've got some glasses.
That's right. That's right.
The glasses are
all ready.
Absolutely essential. You want to put these on as it is starting to have that moon move in front of the sun, and we don't want you to damage your eyes.
Right. Yep.
And it's incredible. You put these glasses on in the normal sun of the day, you can't see a thing.
Can't see a thing.
But when you look at the sun, you will be protected.
Administrator, thank you so much. We really appreciate your time here. And now we're going to head it back over to James at the Eclipse board.
Whew, yeah, the countdown is on. Just a few moments left until the eclipse makes landfall in Mazatlan, Mexico. Right here, you can see where that eclipse totality shadow is right here. It's going to continue moving very rapidly onwards to Torreon, where we also have a live feed covering all of this event. Super excited for that big moment. And let me actually just go to our moon board here, and we can play through this at 60 times speed. I'll zoom in a little bit here. And Scarlett Johansson had a question a bit earlier about the kind of rippling effect that we see of the eclipse shadow. When you first see this right here, at first glance, you might think it's low resolution or we're lacking some kind of information here. The inverse is actually true. This is actually incredibly high resolution, this shadow projection that we have, because of data that we've been gathering at our moon for more than 10 years, thanks to an orbiter called the Lunar Reconnaissance Orbiter. It's been mapping our nearest neighbor in incredible resolution, just really getting every single bit of valley or crater or mountain. All of those little imperfections on the moon are contributing to that shadow that we see rippling across the country. You're not going to be able to see that from the ground, but looking from space, you see that really cool effect of kind of the rippling there here. So let's just preview some things to come here. In Mazatlan, they have that last little crescent sliver of sun. For now, if you're in that area, make sure you keep your glasses on until that sun is completely blocked out by the moon. That's going to be in just a few moments. You're going to have a long duration there, 4 minutes and 17 seconds. That sounds like a lot of time, but it's going to move like that. So make sure you are ready on the pulse. Again, for all of our locations up on this path of totality here too, make sure you set a timer on your watch or a phone or something to remind yourself to look outside and experience this. You don't want to miss this. If you do miss it, you got a long time to wait for the next big one across America. That's going to be in 2045. So make sure you're watching and watching safely here. You just saw some footage from Kerrville and Cleveland as well. It's a little bit cloudy in some places, really hoping that that clears out in time for us to have that beautiful view. But in just a few moments right here, this eclipse is going to be coming up in Mazatlan, Mexico. So for now, this is going to be really exciting. The countdown is on. So for Mazatlan, This is the last little bit here. Again, I'm always keeping an eye on that weather. And also one little note about our tool here too. If you wanted to see, this little icon kind of previews what the expected eclipse is going to look like at that given time. All these little googly eye features are clickable, hyperlinkable. You can kind of click on that. It'll snap you right to that exact time to get an idea for what it's going to look like in your neck of the woods. But for now, the big moment's coming up. Back to you, Megan. Let's check it out.
All right, thank you, James. And as you can see, wow, we just have a tiny little faint sliver left of the sun in Mazatlan, Mexico. We are expecting totality in 1 minute and 35 seconds. You know, joining us now to walk us through this, Kelly Korrick, an astrophysicist from NASA's Heliophysics Division. Kelly, tell us about the science NASA is about to conduct right now in Mazatlan.
So science that they're going to conduct is about the WB-57. So we're going to fly some planes over and make sure that we can actually see that solar corona, that that hot atmosphere that's around the sun that we're about to get once we reach totality.
Yeah, and it looks like it's
almost there.
Yes, it's almost there. You know, we have a view right now of inside the cockpit of one of the WB-57s, or at least we're efforting one, because as you said, this is going to be a huge part of what we do in Mazatlan.
Definitely, yeah. It's the
oh, there it is, Kelly.
There it is. Oh, look at that view.
So we're looking out.
That's great. We're looking out, and it looks like we might be able to. We're seeing a lot of clouds, but hopefully a shadow as well as we're coming in to totality there. And so, yeah, so these WB-57s are carrying 3 different instruments, or 3 different experiments, 2 to look at the sun and 1 to look at our atmosphere, because our atmosphere actually responds to the eclipse. And we're trying to figure out how that ionosphere, that layer of the atmosphere, actually responds to it.
And you said it does look like there's already a shadow over land. You know, we also have a shot, and we'd like to pull that up now, a shot of the coast and the fact that it's already going on over. And you know what's really cool about all of this is we do have eyes all over this thing, because we are collecting so much data.
Yeah, definitely. I mean, we have the stuff here. We also have rockets on the other side of the country being launched to, again, study that. Oh, look at that. That's the diamond ring.
That's right. We're not there, but I feel the energy just watching it.
Yeah, so this is because of the craters and the peaks and valleys of the moon, we're seeing the last bits that are just getting through, and now we're getting to totality. This is great. So you're starting to see those pink fingers out there kind of sticking out.
Wow. So again, totality here in Mazatlan, Mexico, the first community in North America to experience the moon completely eclipsing the sun. And if you are in Mazatlan right now, it is now safe to remove your eclipse glasses for the next 4 minutes. And you mentioned some of those pink filaments that we're seeing, right? Can you talk us a little bit through that, Kelly?
Yeah, so those pink filaments, because they're helium-rich, that's why they're appearing pink, and they're hanging out there. Those could be the start of space weather. So there are lots of tons of material, billions of tons of material that could possibly be one of those explosions for space weather, the reasons why we really study the sun and try to understand how to live with the sun.
Well, can you explain why space weather is important to us here on Earth?
Definitely. So it's not just satellites that are interested in space weather. It's also our power grids, because of those energetic particles coming from those big explosions that can happen in the sun. That could damage our power grids. It could also do things like interfere with GPS signals. And I know we all use our phones to navigate everywhere. So if we didn't have that, that would be a big problem. So we're looking to understand it better so we can all mitigate all those things.
Some of the movement we're seeing here is just our telescope operator adjusting, because again, they needed to make some changes for before totality. Now they're viewing it a different way, and then after totality we might see some shakes there as well. But I really just cannot believe how crisp it is. As we said, it's not a marble, but I mean, just the view of it is so crisp with these little, again, those filaments are just amazing that we can see that to such accuracy, you know?
Right, definitely. And also the white fuzz. I mean, you're seeing something that's 1,000,000 degrees just hanging out all around the sun. And you know, 3 billion Earths can fit inside of there. So there's a lot of atmosphere there, all around there, just hanging out, being very warm. And so one of our mysteries is, and one of the B-57s are addressing.
There you go, WB-57, our pilot.
Yeah.
He's flying. So basically, Kelly, he is going to fly and try to chase down the shadow for as long as possible, keep up with it as long as possible.
Exactly. The shadow is much faster than the plane. However, they can chase it for a while and get an extra 2 minutes. So on the ground, we can only get 4.5 minutes, and they're going to get 6.5 for that plane.
I love that they're waving to us. Oh, there you go. And now we're flipped. Now we're seeing the front. So again, they are in night. I mean, it looks very dark with only some light on in the horizon, yeah?
Right, yeah, and that's what we'll expect wherever we see totality, is the night sky is very dark. You might even see some planets or stars, and then you'll see like twilight all around at 360 degrees.
What an amazing vantage point as well. My gosh. I'm very jealous. Kelly, are you jealous? I kind of feel like you're jealous.
I'm kind of a little jealous. Yeah, I kind of want to, see if I can make a faster plane so we can, follow it the whole way.
Plus, they're up above the clouds, so they don't have to worry
about the clouds. Exactly.
Well, I do want to say a big thank you to the WB-57 pilots and the whole team supporting them for that great view. That was awesome. Kelly, you have a wealth of knowledge when it comes to the sun. And for those watching, if you're interested in learning more with her, check out her and other experts featured in the Sun series of NASA's Curious Universe podcast. And that QR code will pop up on the screen, and that'll take you straight to the episodes. Again, look at that double box we got there. We're showing you amazing views during this broadcast. A big thank you, actually, to the Solar System Exploration Research Virtual Institute, or SERVI, for providing the telescope views from Mazatlan.
Yeah, the SERVI team down there, the SERVI team is based out of Ames, but it is a collection of teams across the country and across the world that are sort of studying the intersection of science and exploration, helping us get ready for our next trip with humans to the moon.
Yeah, that's amazing. Okay, totality is actually about to end in Mazatlan. Let's keep watching our screen right now for, again, what are we watching for, Kelly?
We're watching for the diamond ring effect. So that's when the first bright light, we're starting to see it on the side there. So you're going to put your glasses on right now to protect those beautiful eyes, because now we're going back to the partial phase.
Whoa, that's amazing.
Wow.
Yep.
Kelly, that's a filter, by the way, everyone. That's why we're seeing that. But when you said put on your glasses, I'm so trained now to do it that I almost did it here in Cleveland. No, we're fine in Cleveland. We're still in Mazatlan. Again, what we're seeing is because we needed to adjust the filter now that, again, it's basically like putting on our glasses. The way that you said people on the ground need to put on our glasses, our telescope operators need to protect their own eyes as well as their equipment.
Exactly.
Well, thank you so much, Kelly. I really appreciate your time here with us. It was so fun to learn about the science and actually see the first eclipse come for North America here. So thank you so much.
Thank you.
All right, as you can see, there's a lot to learn about our sun and eclipses. So to explain it all in a really fun way for kids, NASA developed a clever game called Snap It. We have another QR code coming on your screen right now. Just scan that code, or if you're watching us on your phone, all you have to do is screen grab it, press on it later, and you can check out that game. Also the website, if that's easier for you, go.nasa.gov/snapit. Okay, so NASA can predict the total solar eclipse's path to a high degree of accuracy because of a spacecraft that launched nearly 15 years ago. This same spacecraft is now helping our Artemis II astronauts who'll be orbiting the moon next year. NASA's next step in establishing a long-term presence on the moon is sending 4 astronauts to fly around it with the Artemis II mission. Part of the crew's training has been to study images from NASA's Lunar Reconnaissance Orbiter, or LRO. The spacecraft launched in 2009 and continues to use 7 instruments, including a high-resolution camera, to help us learn more about the moon's surface. Because of LRO, we now know more about the moon's topography than any other planetary body in the solar system, including Earth. The Artemis II crew used LRO data and photographs to learn how to identify lunar landmarks they'll see from orbit and to seek out sites of scientific interest, like possible landing spots for future explorers. While helpful for planning Artemis missions, people back here on Earth also use LRO to predict the shape of the moon's shadow, or umbra, during total solar eclipses. The moon's shadow will change throughout the eclipse, depending on the lunar terrain and the elevations of observers on Earth. People may even see what looks like an arc of solar diamonds around the moon as sunlight peeks through lunar features like craters. That's a look at your Artemis Moon Minute. All right, joining us on the host desk now is a familiar face here. Oh, actually, sorry, Snoopy. Oh, I just revealed that it's Snoopy. Well, I just want to wave real quick to the crowd here at the Great Lakes Science Center, just outside of our host desk, waving at us, waving at the camera. I'm waving back at them like they can see me. But I did just spoil the surprise. We do have Snoopy here, our Chief Safety Officer here at NASA, and he's here to tell us how to safely watch the eclipse. So, Snoopy, if we were to watch the eclipse today before totality, what should we do? That's right. You should have your glasses on. That's right.
Well, and what about during totality, Snoopy? Can we take them off then? Yeah, let me help you out here.
Oh, Snoopy, there I can see your shining bright eyes. I love Snoopy. He's so funny. Now, Snoopy, I have to ask you a question, okay? So today we've been polling everybody, asking for the total solar eclipse today, who is the big star of the show, right? Is it the Earth? Is it the Earth? Is it the moon? Is it the sun? Okay, but you have to pick one.
You have to pick one.
You have to pick one. You don't want to pick one?
All of them.
All of them are great? That's right. Snoopy, thank you so much. I know you're super excited to see the total solar eclipse today. We're glad to have you here. Bye. All right, now let's head back over to Tahira in Kerrville, Texas.
All right, thanks, Megan. I mean, what an incredible view from Mazatlan, Mexico.
That was amazing.
And folks, as you can see in your screen right now, we are less than 1 minute away from the eclipse, crossing over Torreon, Mexico. Gina, how fast is this moon shadow moving right now?
I mean, it's flying. It's going about 1,900 miles per hour as we're chasing it across the U.S.
That is incredible. And so, you know, in Mazatlan, we were able to see the diamond ring effect.
That's right. It was beautiful.
Beads. So hopefully we'll be able to see that in Torreon right now.
Yeah, we're watching that live feed.
Yes, just to see this sliver crossing over the moon.
That's right. We're getting so close there.
We are
Hopefully
getting
we'll see
so
that diamond
close.
ring too.
Wow. Look at this. And so we're about 10 seconds away.
Here we go.
Let's take it in. Wow. What a spectacular.
It's going into totality.
Wow. There you have it. We are in.
Yep, that diamond ring came through, and we see a little bit of those Bailey beads too as we're looking at it. Those kind of the lights trickling through around the surface of the moon, coming through the peaks and valleys.
So what are we viewing on the left-hand side? This almost pink color effect.
Right, and so as we just heard from the last totality, you know, these pink fingers are popping out a little bit, and those are those solar prominences. They're appearing pink because of the helium rich, but we can see it. Let's focus on the corona here, that glow that we're getting, and we can see basically these streams that are coming out, a lot of that energy and brightness that we do not have the ability to see on a day-to-day basis. So with this total eclipse, we're able to see that corona nice and bright coming through in Torreon.
That is just a magical view. Oh my goodness,
It is.
Gina, okay, and so we've got so many questions coming in online right now from viewers watching this. Our first one is going to be from Justin, who wants to know, you know, right now we are seeing a pretty clear and spectacular view of a total solar eclipse.
Yes.
But Justin wants to know, what will it look like if it's clouded over?
Right, so the view that we're getting right now, you won't be able to see that if it's clouded over, but you will have effects going on, right? You'll get a change in the temperature, so the temperature will drop. It'll still get darker as well.
It's already getting dark here in Kerrville.
I mean, we have some cloud coverage, right? And we're feeling a little extra wind. It's noticeably darker despite the clouds that we have, so you'll get some of those environmental effects, even if it's cloudy where you are.
And so a great follow-up, you know, we've got Halloween Ghoul on YouTube who wants to know, again, will the temperature change during totality, which I know you mentioned that it will get a little bit cooler.
Yes.
But do you know about how many degrees we can expect?
Yeah, you know, it depends on the location, the humidity, multiple factors, but it can change by about 10 degrees or so, depending where you are, maybe even a little bit more than that. And, you know, we're feeling a little chilly kind of where we're sitting compared to what it was earlier. And, I mean, I'm just staring at this view of totality that we have in Torreon.
So we're about halfway through totality right now in Torreon, Mexico. And again, I know folks said that this is almost double totality than 2017, right?
That's right. That's right. And so in 2017, we had a little more than 2 minutes. So we're lucky enough this time that we have over 4 minutes in some places, too.
This is so beautiful. And so our next question from Sibel on Instagram wants to know, why is the sun more active right now?
Oh, so the sun is more active because we have an 11-year solar cycle. The sun goes from solar maximum to solar minimum, where it's changing its level of activity. Oh, and as you're seeing the screen, yeah, so I see in that the bottom right there, we can see that prominence extending out. And as we heard earlier in Mazatlan, you know, that is potentially the beginning of space weather activity. So we're talking about solar maximum. If there's a time to see any of that space weather activity during the total solar eclipse, this is the time to do it. So let's watch that as we go through totality and our other locations too, and maybe we'll be lucky to see some of these features change for us.
That is so beautiful.
It is.
And so Gina, too, you know, how we're in a higher cycle, solar cycle right now. How many years, you know, is that fluctuation?
Right. The solar cycle goes on for 11 years when it peaks in activity, and that's where we are, where the latest predictions are that we will reach that maximum sometime this year, and then it'll decrease in activity going back down to solar minimum.
And so, Gina, I've got time for one more quick question from Christopher on X, who wants to know which other planets have the best eclipses.
Oh, okay. Well, that's right. So eclipses don't only happen on Earth. Let's talk about Mars, for the fact that Mars does have eclipses when the moon crosses in front of Mars. Mars has 2 moons, and the rovers on the surface have captured images of those.
But no other planet has a view quite like this, right?
Nope, that is special for us. Just the distance and the size of the moon makes it such that it will completely block the sun as it's doing today.
Wow.
And you can see there's that diamond ring effect as we are coming out of totality in Taurion.
What an incredible
Wow, it's a bright one
view.
too. Look at that.
That is a bright one. So is this what, a Bailey's bead? Or
so that's going to be that diamond ring, just how bright it is. Bailey beads are a little bit smaller as they kind of bubble over the surface, but folks who are in that location should have those safety viewing glasses back on so that they can now view the partial eclipse that they are experiencing.
Well, that is fantastic. And you know, the next time we see this eclipse, it's going to be right here in Kerrville, Texas. So folks, the countdown is on. We've got about 10 minutes until we see this with our own eyes.
You can hear people
Yes, big moment right here in Kerrville. For now, let's check back in with Lauren at the Indianapolis Motor Speedway.
Thanks to Hira. We are getting close to eclipse ourselves, but for now we have a very special guest, NASA's very own Pam Melroy, Deputy Administrator and former astronaut. Pam, it's good to see you.
Oh, it's great to be here. I'm so excited.
It's very exciting. So what's it like being in Indianapolis for an exciting event like this?
Well, it's a beautiful day here, and I love the fact that we're here with thousands of people in the Indianapolis Motor Speedway. But we're joining with millions of people around America looking up together to the sky.
Absolutely. And tell me, is this your first eclipse?
It's not my first eclipse, but it will be my first totality. I've seen several partial eclipses, but there's something mystical and mysterious and in some ways unifying about a total eclipse, and we're all going to feel it together.
Absolutely. We could not have lucked out more on this weather today. So as a former astronaut, we know that sun science and space weather are very important to keeping our astronauts safe. What is space weather, and why do we care about it? What is NASA doing to study it?
Yeah, that's right. It's actually very important. It is of concern for astronauts who are in space because they experience the radiation of the sun that comes from solar flares and solar weather. But the reality is it's also affecting life here on Earth. It impacts the upper reaches of our atmosphere called the ionosphere, which is an electrified part of our atmosphere that is a conduit for communications. It's critically important. It can even affect power grids. And of course, if you ever have seen the Northern Lights, you've seen the effect of solar weather. But really the focus for today is where that solar weather starts, and that's in the corona, the sun's atmosphere. It's very unusual, and we don't exactly know what's happening because the sun's atmosphere is millions of degrees hotter than the surface of the sun. So we are hoping to learn today more about how that happens and why that happens so that we can better predict those solar flares and those things that impact us here on Earth.
Yeah, that's all extremely important and something that we're learning a lot today too. Pam, thank you very much for joining us today.
Thank you.
As we've learned, solar eclipses are very important to learn for many, many reasons. We have radio telescope operators who are studying the eclipse today for this very reason. Let's take a look at that work.
When the moon blocks the sun during a solar eclipse, there is a noticeable impact on Earth's upper atmosphere, known as the ionosphere. These changes can affect radio communications, including amateur radio, also known as ham radio.
Ham radio is a way you can talk to people all around the world. You set up a radio and antenna. You talk into the radio sends a signal up to the antenna sends the signal up to the sky. It bounces off of the electrified layer of the sky back down to Earth, where you can talk to the person on the other side.
During the 2024 total solar eclipse, the HAM-SCI Citizen Science Project is inviting ham radio operators to transmit radio signals. The goal is to have people make as many radio contacts as they can with operators in different locations during the celestial event. By recording how strong their radio signals are and how far they go, ham radio operators and scientists can learn about how the ionosphere changes during solar eclipses.
Sometimes you can talk around the world, and sometimes you can't. And that's all based on what the ionosphere is doing, what the sun is doing. When it works and you are able to talk to these faraway places, I find that really magical.
To learn how you can participate, follow Do NASA Science on X and Facebook.
And we are minutes away from the total solar eclipse over Kerrville, Texas. The temperature is dropping. As you can see, I had to throw on a jacket. The sky is dimming. We're on the edge of our seats, and we are joined now with astronaut and commander of the Artemis II mission to the moon, Reed Wiseman. Reed, it's an honor to have you here.
Thank you. The crowd noise, the fact that the sun is behind the clouds most of the time and peeking out, it's so wonderful.
I know.
True. Thanks for being here, Reed.
As you can hear, we are ready.
We are right there.
So exciting. So tell us, Reed, obviously everybody is excited, but have you seen a total solar eclipse before?
Never a total, so I will share this darkness with you and this whole crowd the first time.
Oh my
wow,
gosh,
this is incredible.
That's
so
great.
too, what considerations do you and your fellow Artemis astronauts need to think about when related to the sun when traveling back to the moon?
Well, it's great to see Pam Melroy on your last clip, a dear friend of mine, so it was nice to see Pam's face over there. But when we're heading out to the sun, it's really radiation is our big thing that as we're heading out to the moon.
Yeah.
It's really the
Not the
solar
sun.
radiation that we're most thinking about there as the danger from the sun, and the Apollo astronauts dealt with it, and we've dealt with it for a long time on the International Space Station, and we have a lot of data from the moon, from our NASA probes that have gone out there and collected, so we think we know what we'll encounter.
Great, okay. And tell me, Reed, how does it feel to be the commander of NASA's first crewed mission going back to the moon since Apollo?
I am flying with Victor Glover, Christina Cook, and Jeremy Hansen, the three best.
Team, yes.
I know, so every day that I go into work, I won't say every day is easy, but every day is fun, and I'm flying with people that have principles, they have integrity, and they have just so much knowledge and professionalism. It's a dream come true. And getting to work with the whole team, the international team, it's the best.
Wow. Well, thank you so much for being here with us, Reed. Really quickly, do you have any advice for anybody that might want to follow in your footsteps one day?
We always say that you have to find that job that you love, go all in on it, live your best life, be as good of a professional as you can, and someday apply for the program. And we look forward to seeing your application come across our desk.
Thank you, Reed, and good luck on your upcoming mission.
Thank you. Great to be here.
Now, if anybody feels like reaching for the stars, NASA is actually currently accepting applications to be an astronaut. You could one day travel to the moon and eventually to Mars. From teachers to scientists to even those in our armed forces, we are looking for a diverse group to take humanity farther into the cosmos. You can apply now through April 16th by visiting go.nasa.gov/astro2024. Now, timing is everything when it comes to pulling off successful science during an event like today. Let's hear from a very special guest who also knows a thing or two about perfect alignments.
Hi, I'm Paul DeYoung, shortstop for the Chicago White Sox. What does it take to do my job? Gotta know your physics. I specialize in predicting the path of fast-moving objects at a split-second pace. At my position, it's key to know exactly where and when two paths will cross. Just like NASA needs to know when the Earth, Moon, and Sun will align to predict the solar eclipse. Working it all out on the whiteboard is one thing.
They're ready, folks. Solar eclipse delay at Volcano Stadium.
whole other ballgame. And on April 8th, you can see just what I mean as a total solar eclipse crosses the United States. NASA has mapped the detailed shape of the moon's surface, so we know exactly where the moon's shadow will fall. And you know where to be to see the eclipse in person, even if it's from the stands. Don't miss your chance to experience the beauty of science in action, and maybe catch a ball game.
You actually can't see it. We are 2 minutes, about 2 minutes, under 2 minutes actually, away from totality here in Kerrville, Texas, which will mark the start of our eclipse coverage across America. Now, folks, we have a little bit of cloud coverage right now in Kerrville, so we are showing the Dallas feed. But again, we're holding out hope.
We are.
Gina and I are thrilled to be here with Dr. Nicola Fox, who is the Associate Administrator of NASA's Science Mission Directorate. Nikki, thank you for being here.
Oh, I wouldn't be anywhere else. Thanks for being here, Nikki. So tell us how the science conducted today will really impact the future of exploration at NASA Science.
Oh, wow, there's so much that we're going to be doing today. We're going to be studying the sun. We're going to be studying the Earth's atmosphere and how that changes. You can see it getting dark here. And, you know, we've got these little magnetometers. They're going to be all across. We have 30 of them all the way across. I'm going to hold it up.
Very nice. Love magnetometers.
Magnetometers, and we're gonna be having these all the way across the path of totality. And it sounds like we should go. We should get up.
All right, let's go.
Let's go. Oh my goodness. Less than a minute. Oh my goodness.
Wow.
Okay.
All right, glasses on, Nikki? Yes?
Yeah,
or
glasses
no?
on, but we're about to get. Yeah.
There's some cloud
Yeah, there's
coverage.
some cloud coverage.
It's trying to peek
It
out.
is trying. It is trying. It is trying. It
Windy
is getting
for
dark
sure.
here. The wind's picked up. You could actually see the birds started flying in a very weird pattern a minute ago.
Good point.
Come on, clouds.
Everyone's
Wow.
screaming.
Yes.
You know, I might have to switch to Team Sun.
Come on. Oh my goodness. We're there. We're nearly there. Okay.
Here we go.
Wow, the crowd is counting down.
Wow. Yes.
Oh my gosh, it's beautiful.
Yes.
Oh my goodness.
That is amazing.
Wow.
I told you. No, go away, clouds. Go away, clouds.
They're
Look
gonna
at
move.
that. Oh my goodness.
Goodness.
I have been saying all day. Look how dark. Look how dark it is around here. Yeah.
It is just this white ring.
White ring.
Yeah. It's so dark.
It is so dark. It is
You
so
can see the
dark
planes
here.
in the sky
You
much
can.
better.
Wow.
You can.
Everybody's
We have
just
planes and
screaming.
helicopters and drones
The whole
all over
crowd
the place
is
today.
just
Look
Here we
at
go.
the clouds are going to clear
Look
for
at
us.
that. Yes. Yes. Woo!
Oh my
Look at that. Just
It's
look
amazing.
at that. That is
And we have
incredible.
about, what, 4 minutes
Oh, yeah.
to
4
just
minutes
bask
and 25 seconds.
To be
Yes.
I mean, this really,
Yes.
again, reminds you that we are on this one planet, you know,
Yes.
in this larger system.
And you have to be on this planet to see what we're seeing.
You do.
right
That's
now.
why we are Team Sun, Earth, and Moon. Because you need the moon for an eclipse. You need the sun for an eclipse. And we're
Right.
standing on the Earth to see it.
Oh, man.
So, all of
Amazing.
NASA science represented by a total solar eclipse.
And something that, what, over 30 million of us today, at least
Yeah,
in
at
the path
least.
of totality.
At least, yes.
Able to witness
yeah.
this.
31
about
people
you,
living in the path of totality. So
Doesn't
imagine
count
how
who
many people
travels.
actually traveled here. Yes.
Absolutely.
Yes.
This
Wow.
is getting me extra excited about all the science that
All the science that we're doing.
right?
Yes. Yes.
All right, those clouds are playing tricks
Those
on us
clouds
now.
are being pretty mean. Yes.
It was nice to get a taste, though. Wow.
true.
It is
Yes.
so dark.
It is.
We've got everybody
it is
looking
so
up.
dark.
I'm so happy that, you
Yes.
know, for folks that
good.
travel,
Yes.
able to see this take place.
That's right.
And
so-
it's been such a
waiting.
great atmosphere here all day. Every
Yes.
time the sun comes out, everybody
Everyone's
cheers.
cheering,
Yeah.
counting down. It has been incredible. And so, wow.
That's true.
Oh, Nikki, what's your favorite part about about an eclipse? Is this your first?
No, this is my second one, 2017. I was in Nebraska and I saw it there. But I think there's just, you can study the sun, you can study the corona, but suddenly you see it with your own eyes, and it's that feeling of just, wow, that is our star. Like, that isn't just, it isn't just the sun anymore. That's a star, and you see it looking like a star. And as we study, as we look for exoplanets in other galaxies that might be able to support life, we need to understand our relationship here on this planet with that star. And so it's so important. And I think when you see it, you're just like, wow, it actually is a star. Yeah. It's not just a bright point of light in the sky. You can see the structure. You can see just how exciting the sun is, and actually how dynamic it is.
Yeah. And it's not often in heliophysics that we can actually see the science that we're doing with our own eyes.
That is right.
So it's a rare experience.
Or even share in it, millions of
have
us
so
today.
many people partake.
Yep.
That's right. It's pretty windy too here.
It is windy. And so I know earlier in the show we've mentioned that total solar eclipses really might only pass through a certain location, say every 375 years.
Mm-hmm. Yeah.
Can you explain how come we don't see eclipses like this every day?
month?
Mm-hmm.
Yeah,
every month.
Because the moon's orbit is actually tilted, and so most of the time when it passes in front, it doesn't block out the light for us. At this particular time, it is right on the plane between the Earth and the Sun. It is actually at its closest point to the Earth, and so in the plane of the sky, the moon is exactly the same size as the sun, and that is very unique.
That is so special, too. I mean, like, what are the odds?
It's the 400s, right? It's the distance between the Earth and the moon is 400 times closer than the Earth and the sun, and the size is 400 times smaller as well. So it just blocks it perfectly.
Yep. It does, and right now the clouds are blocking it perfectly.
Hey, but we got a taste of it, which was very nice, and we are chasing this eclipse across North America today.
We are.
So excited to see it from these other
I think it wants to come out again. I don't know. These clouds are thinning.
Yeah, the clouds.
You can hear the crowd
cheering, getting excited.
We're hopeful.
Yeah.
Channeling all that good energy.
Yeah. This crowd has been great all day.
Oh, yes.
All day.
It's crazy to believe, too, that it was so dark and it's only like midday.
Oh, yes. Yes. Yeah.
Wow, and we're starting to get
starting to get the light back.
Yeah, starting to get the light back.
Yep. So unfortunately, we did not see the diamond ring at the end of the eclipse because of the clouds, which is always a crowd pleaser. But we did see it actually right before totality. There was suddenly this beautiful bright one light, and then it all went dark. So we did actually see quite a few great features on the sun, and somebody actually was saying they could see a sunspot. Obviously through their glasses, but they could see a sunspot. So
can you clarify what the sunspots are for our viewers?
Yes, absolutely. So if you were looking through your glasses, you might have seen a couple of dark spots on the sun. They are actually very intense places. There's very, very intense magnetic field there. They're very active, and that is what can cause space weather. So every now and again, those active regions can sort of explode and then send billions of tons of solar material towards our planet.
Wow. Well, this was fantastic. Thank you so much, Nikki. This was incredible to experience this with you. Let's follow this eclipse right up that path. Next up is Dallas. We have Joy and Michael standing by for their big moment in the sun.
Yeah, you can feel the temperature change. The wind has completely quieted down. Yep.
So the energy here is amazing. So with me right now is Dr. Michael Kirk. He's one of our eclipse experts. Michael, we saw an annular eclipse back in October, but today is a total eclipse. How are you feeling today?
It is totally different. I am ecstatic. The annular eclipse was really cool. This is, you can feel it, the energy here is electric.
If you look around, you can see that the darkness is coming. Let's have a quick look at what we're looking at right now. We're almost there. We're a couple of minutes away.
Ooh, yep. Just a crescent left.
So let's quickly talk about some of the ways that the public are participating in the eclipse right now.
Yes.
Michael, can you talk about some of the citizen science projects?
Yes, there are people all around the country right now making measurements of audio recordings to see how the environment is changing. And it is a great opportunity to do genuine science with just an audio recorder.
Fantastic. So we are almost like, let's see, a few minutes away. So minute 30 out, I think, actually. So let's have a look at the eclipse. Michael, what should we expect to see moments before totality?
Okay, so as we approach totality, you're going to see that crescent sun slowly drift away, and then you're going to see the Bailey's beads, where there are these bright points of light that are last bits of sunlight cascading through the moon valleys. And then right before totality, you'll see a diamond ring, that last single point of light, and then we'll be in totality. We just have a thumbnail of sun left. We are closing in on totality here.
Wow, we see a sliver of the sun left. Remember, you can only take your safety glasses off when the moon has completely covered the sun. And in Dallas, Texas, we are seconds away.
Oh my goodness, I can feel my heart racing. You can hear the crowd getting excited. The birds are chirping, and they seem like they're going into their nighttime routines.
Wow. So we are a few seconds away. You can hear the crowds cheering.
Here we go. Oh my goodness. This is absolutely ecstatic.
The darkness is coming over Dallas.
Here we are. Just a few seconds left.
10 seconds.
Woo! Oh, I'm so excited.
Okay, we are 5 seconds away from totality.
One little bit. It's totally dark here. Deep twilight around here.
Wow. You can hear the crowds.
The last bit of lights, and we're in totality. Woo! Oh my God.
Oh my God.
That is absolutely breathtaking.
Oh my God, Michael. How are you feeling right now?
I am just awestruck. I mean, there's a few high clouds, but the beauty of the corona is clearly visible. You can see that spiky structure just poking out. It is heart-stoppingly beautiful.
Oh my goodness, I have tears in my eyes. I was not expecting this.
This is one of those experiences that you just never forget. I feel so special to be right here, right now, experiencing it, and knowing that people literally across the nation are doing the same thing it's truly amazing.
Wow, let's take a moment to take it all in. This is absolutely breathtaking.
Wow. You can see that spiky structure of the corona. That's indicative of our approach to solar maximum. That asymmetrical nature of the corona happens when we're in solar maximum. That's going to be happening in about a few months from now. So that means that this view of the corona will never happen again, ever. This is a completely unique view that even if you see a million solar eclipses, you'll never quite see one like this.
So, Michael, you study the sun. What is it like to see the corona that you don't normally see?
I mean, there are no words. I spent my life studying this thing, and to be able to see it and feel it it's just tremendous. You can see a prominence in the chromosphere, the middle atmosphere of the sun. It's a pink spot, and that pink loop is what I spent 5 years doing a dissertation on. that one little pink loop, and it makes it all feel like it's in perspective now.
I can't believe how clearly I can see those pink loops and the structures in the corona.
We can see a few planets out as well. They're brightly shining in the sky, and actually there's a plane racing across the shadow as we speak as well.
And I just want to take a moment to say huge thanks to our telescope operator, Vanessa Thomas, for providing these views. This is just so stunning.
People are applauding here, as you can hear. I mean, I think everyone here is getting exactly what they came for, which is just that sense of your place in the universe. This is our closest star, and being able to see the star like this is truly special.
Okay, we have 1 minute left of totality.
Oh, the time just passes way too quickly.
The next eclipse won't happen across the U.S. for another 20 years, so this really is a once-in-a-lifetime opportunity for a lot of people.
Absolutely. Our friends up in Alaska will see their next eclipse in 2033, so I am like already thinking I need to go there. I mean, it's just
Yes, definitely.
it doesn't matter what I need to do. I just have to go there.
Wow. So we're 30 seconds out.
Oh, my
so
goodness.
right before totality ends, our telescope operator, Vanessa, is going to put the solar filter back on. But let's just cherish these last few moments of totality in Dallas, Texas. Michael, what will happen right before totality ends?
So as totality is ending, we'll go through the process in reverse. You'll see maybe a diamond ring, a few Bailey's beads as the sun creeps out of totality. And then we're going to go back into a crescent sun again. Okay, and there's a diamond ring again. So time to put your glasses back on. And that
Sunglasses back. Sorry, eclipse glasses back on.
And it's coming back again.
Wow, the slither of the sun.
And you can see shadow bands on the ground right now. It looks like it's almost raining, or you can see those shadow bands racing across the ground as we come back in out of totality.
Wow. Whew. Oh my goodness, Michael, that was amazing. I was not expecting to feel so emotional. I still have tears in my eyes.
It just grabs you. It is unlike anything else. It's as amazing as seeing anything in the natural universe. Like I said, there are no words.
Michael, thank you so much for being with us in this very, very, very special moment.
I feel honored to be here. We truly are in a special place in the entire universe right here, and I'm just so happy to share it with you.
So now let's head back to James at NASA's Kennedy Space Center, who's with the Eclipse moon. He's tracking the shadow moving across the U.S. James, how are things looking on your end?
Yeah, wow, Joy and Michael, really cool view there. It's insane to see just how dark it gets. It's literally like nighttime there. You can hear the birds chirping in that shot as well in the gardens. Absolutely beautiful. We got a bunch coming up in just a few moments here. Our next eclipse path target here for the NASA broadcast is in Russellville, Arkansas. They're going to have a long window too, 4 minutes and 12 seconds. They're expecting that totality kickoff at 1:50:05 to be exact. Again, you can continue to track this with our eclipse tool here. This is at go.nasa.gov/Eclipse Explorer. And you can see just how quickly it's moving. I'm playing this in real time. You can see that shadow. It's already moving very quickly to the northeast. And the fun isn't just for our friends on the path of totality, and there are a lot of people on that path of totality. About 31 million people reside somewhere on that path of totality. But there's a lot of people obviously outside of that path as well too. If I put on this overlay here for the percent coverage, a lot of folks, us included here in Florida, are experiencing that partial eclipse. As always, if you are in a partial eclipse, be sure to be wearing those eclipse glasses to protect your eyesight as you're viewing it. But you can see these bands here are greater than 75% view. So say you're watching up in, I don't know, Milwaukee here, for example. You've got a great view, almost 100% coverage. You're not quite at totality. 89.4%. Looks like you got good cloud cover there. 20% cloud cover. So hopefully you got a nice view up there as well, too. I've also put on this overlay here to show you just the amount of the duration of totality. You see a lot of our places are within this middle band right here that are getting more than 4 minutes. It may seem like a lot of time, but as you've seen just how quickly that can go by. Michael sounds like he wrote his whole dissertation, a 5-year piece on those just few moments there. This just passes so quickly. And again, if you miss this, the next time you're going to have to wait for this in the U.S. is not going to be until 2045. So again, make sure you're previewing exactly when to expect that peak time of coverage wherever you are in our path of totality or even outside of that path of totality. So a lot coming up very soon. Again, our friends in Russellville look like they have great coverage there as well too. Only 9% cloud cover, so hopefully they're getting a really nice view. But let's check in with Jasmine up there to see. Hopefully you're looking good for there. How's it looking up in your way up in Russellville?
I'm just looking this way.
Everything is looking absolutely fabulous here in Russellville. We could not have asked for better weather. So we are back here in the downtown depot area, and joining us now is heliophysics expert Dr. Patrick Kane, all the way from DC. How are you feeling about your very first total solar eclipse?
I'm incredibly excited. As I'm watching all of the changes, there go the crowd. As I'm watching all of the changes, I'm thinking back to the textbooks that I've read, and so it was all academic before. This is no longer academic.
Yeah, so the feeling is very different than what we might read in a textbook. Patrick, just explain, describe the atmosphere around us as it's changing.
Right now, as I'm looking around, of course, the temperature has been falling for the last 20 or 30 minutes, but the light is dimming, and it's dimming faster and faster and faster. It seems like it's accelerating. The crowd is definitely getting excited. I'm looking around the ground to see if I see the shadow snakes. I don't, but this is just really exciting.
It really is. Honestly, like you said, we're feeling that cooler weather.
Yeah.
The crowd behind us just erupted. We're also feeling them fall a little bit quieter, too.
Right.
So we're going to take a beat of silence as we get into totality. I think we're less than about 15 seconds away. So we're going to also look over our shoulder with our solar eclipse glasses still on until we are in totality. Here we go. Just a sliver of the sun left.
Getting close. Crowd's getting excited.
The crowd, yeah, all around us, completely electric.
Going. Wow.
Oh my goodness. Here we are.
Here we go.
And the crowd goes wild.
God. Oh my God.
Wow.
We got some Bailey's beads.
Absolutely stunning.
That is spectacular. We see Venus over to the side there.
And Patrick, it came and went so quickly, but we did see a diamond ring at the very beginning there. Can you describe to us what is that?
Sure, that diamond ring effect is due to the moon not being perfectly smooth. It's got mountains, it's got valleys. So just like here on Earth when we see a sunrise or a sunset through a valley, we just watched a sunset through a valley on the moon.
Absolutely stunning.
Oh my.
So you said we could see one planet. I see it right there in the sky. Can we see any others as we're looking up?
Yeah, we've got Venus on the over to one side. We've got Jupiter up here to the left of the sun. And there's the corona.
Absolutely beautiful.
That is spectacular.
Now, you also said that this is happening during what we're calling a solar maximum. Now, Patrick, does that mean that the sun is stronger right now than normal?
Not so much stronger, just more dynamic. It's changing a lot. During solar maximum, the magnetic field on the sun is more chaotic, it's more disorganized. So you see more random directions for the jets of gas leaving the sun.
Right.
That is spectacular. We could see a stream.
All right, we are reaching that halfway mark already, 2 minutes into totality.
There's even just a hint of a diamond ring down at the bottom.
I can see it. Yeah, we're looking at a diamond ring from Arkansas, the Diamond State. Now, Patrick, of course, as we've been talking about it, this is part of what we are calling the heliophysics big year. You are a heliophysics extraordinaire all the way from Washington, D.C. So what does that mean?
Okay, so the heliophysics big year started out in October of last year with the annular eclipse. And of course, we take a pause here in the middle to watch this particular eclipse, but then it will end on December 24th of 2024 when Parker Solar Probe passes as close as it's ever going to get to the surface of the sun within 9 solar radii.
Oh, wow. And I'm sure that means a lot to you because you worked on Parker Solar Probe about 20 years ago during its inception. So tell us a little bit more about that.
I worked on a concept study for Parker Solar Probe back when I was a graduate student in around 2002 or so. And back then, the idea was for it to actually dive into the sun rather than orbit the sun. So it was going to be a sun dive.
Wow, that is fabulous. This must be a very full circle moment for you, right, Patrick?
This is brilliant. This is absolutely brilliant. And that diamond ring has been Wait a minute. That's pink. What we are actually seeing is down into the chromosphere now of the sun. We're seeing a little bit deeper than the corona. I believe it's because of the pinkish color. We're looking down into the chromosphere, which is the next layer of the atmosphere of the sun down.
Oh, wow.
Wow. Oh my God.
This is like nothing we have ever seen here in Arkansas and like nothing we will see for the next 2 decades, right, Patrick?
That's right. It's going to be 21 years before we see it again here. 2045.
All right, so as we are starting to exit totality, of course, we're going to be very careful with our eyes if needed. We're going to put those solar glasses back on, of course. And the crowd just erupting, falling quiet again as they watch this magnificent moment take place.
I am actually seeing bats flitting through the air.
Oh, wow. Well, we will be very careful then.
Well, yeah.
And why is that, Patrick? Again, those nocturnal animals are coming out, right?
As far as they're concerned, it's nighttime. It's time to feed. So they're coming out to feed on all the mosquitoes we've been swatting.
Okay, got it. We'll be very careful for all those nocturnal critters around us right now.
All right. We are getting closer. Get ready to put those glasses back on.
All right. We're putting those glasses back on. The crowd wow, a second diamond ring seen from right here in Arkansas, the Diamond State. Absolutely stunning.
Outstanding.
Beautiful. Patrick, we're going to turn around now and just one question I really do have to ask you before we let you go is, are you Team Sun, Moon, or Earth?
I am Team Sun all day long.
Fantastic. I figured from a heliophysics expert like you. We want to thank the city of Russellville for hosting us, Arkansas Tech University, and our telescope feed operator, Joe Mattis. Thank you so much. Now, let's get back to James Traley over at Kennedy Space Center. James, back to you.
Yeah, thanks so much, Jasmine. What have you guys had there? So you were just right here in Russellville. You can see that shadow has now officially moved off and is on our way to our next target, which is up here in Carbondale. Carbondale is one of those very lucky cities because back in 2017, they were right at that intersection point of the 2017 eclipse across America. They're there again this year, but the difference is they're going to have a much longer slot. In 2017, they only had 2 minutes, 40 seconds, and that's not as much as they're going to have this year, which is 4 minutes and 10 seconds in the totally eclipsed sun. A really great viewing window for them to really take in this big moment. Very exciting to be able to track that for them as well. And also some details about this tool here as well. If I click onto their eclipse time here of 1:59:15 local time, you notice this little icon comes up here. This is actually simulated based off real data from the Parker Solar Probe of what we expect the corona around the sun to look like. And as you just heard, the sun's a lot more active this time around. It's kind of like a wild hairball, if you will. Lots of different streamers and things streaking off the sun. So you've been seeing already in our coverage some really cool activity around that sun's corona. If you're really lucky and the timing is just right, you might get a coronal mass ejection streaking off the sun. Hoping that someone on our path gets to see that today. If you do, be sure to send us the photos. We love to see that as well. One other cool feature about this tool too is you can see the actual path that the moon is going to be taking across the sun. And all of this plays in real time if you time it up well. And so you can actually see, if I go to our live moment here, this is actually playing as what we're expecting in real time, the movement of the moon across the sun. Carbondale just had a little crescent there, and you can see that shadow is really closing in on them very quickly. Let me turn off the 2017 path and zoom in a bit here. You see there, nearing totality in just a few moments, and their weather is looking great. We've been checking in with them all morning and afternoon. 27% cloud cover. That time of totality is coming up at 1:59:15. Really excited. And then it's going to be kind of bang bang for a while afterwards for a lot of our sites. We're going to be moving on to Indianapolis, all the way up to our final target in Holton, Maine. There is a lot coming up. And even again, still, if you're outside of that path of totality, have your glasses at the ready to be able to observe that partial eclipse. This is going to be going on for a while. But for now, let's take a look at Carbondale and see up close what it's looking like. How is it looking over there in Carbondale?
Couple more minutes.
Well, the crowds are going nuts here in Carbondale at SIU at Saluki Stadium. Bob Baer is with us, and Bob, it's amazing. I'm afraid to look up. I know it's not quite ready yet, but tell us, what do you expect here for the eclipse today? Good weather.
It's good weather right now. We have high clouds, so totality is going to look just a little bit fuzzy to us, a little bit hazy, but we are moments away from seeing the diamond ring here. This is awesome.
Oh, I thought we saw it.
I think we got about 1 minute.
Okay, 1 minute away. Now, today we're having longer totality. So
Yeah.
are you feeling the temperature change? Because I'm already feeling the temperature drop.
I felt the temperature dropping about 20 minutes ago even, and the wind picking up a little bit. And I think, yeah, we have 4 minutes and 9 seconds here, so it'll continue to get cooler. And we got a lot to look at in the sky.
I'm very excited. I'm looking up when I can.
Oh, it's so close.
It's getting very dark right now. Very dark. You can see the shadow going across.
This is the start of it. It's dark over here. It's light over there.
This is
The shadow's
amazing.
coming.
Crowds are going nuts. We're about to get word that we're at
That's
totality.
Venus.
Oh, you can see the planets. The crowds are going nuts. This is crazy. Bob,
Oh my
this is
God.
amazing.
Here we go.
Don't look at the
Close.
sun yet. It's
Really
not quite
close.
totality, but you can still see some of the planets right away.
Very close. You got about 15
And the crowd
seconds.
is very happy.
shadow bands.
Oh, total darkness here. This is incredible. Oh, wow.
There it is.
There
Diamond
it is.
ring.
Diamond ring.
Diamond
wow,
ring.
it's amazing.
Hold
It's
the
amazing.
filter.
That is awesome. Look at that. Oh, and Bob, that's amazing.
Wow. Jupiter.
Complete totality. I see Jupiter.
Oh my gosh, that is gorgeous.
Wow, this is amazing, Bob.
Wow, that is huge. So we have some prominences. I think we want to go look through the scope.
Go through, look through the scope. I'm going to walk over with you as you talk through the scope. We are right here at one of the telescopes that we have positioned here. Bob is looking through with the naked eye and
so you got
going to give us some feedback on that. Maybe some prominences we're seeing. What's amazing is how dark it is compared to 2017. Much darker, a lot more astronomical features. We have seen Jupiter, and I believe what planet is that, Bob?
That's Venus
to the right. That's the Venus.
Can't quite see Mercury. I think it's obscured by those light clouds.
Yeah, light clouds.
But 360-degree sunset around us.
This is amazing.
It's going to get darker.
It's going to get darker.
It's going to get darker.
Wow, this is already pretty dark.
We are not in the middle of the shadow quite yet.
Wow.
Did you see it?
Yeah, timer's started.
Okay, 2:46 to go. Okay.
Yeah.
All right, so we're getting some live data from the team here. I tell you, it's really impressive, Bob, because...
Oh, my gosh, it's getting better. See that prominence at the bottom
Yes, at the bottom, there's a prominence. I see it.
Wow. I keep looking for
I can't
Mercury,
believe the clarity. It's so much darker than 2017.
It's gorgeous. And what's awesome, we have 6 telescopes running back here, capturing data, streaming this.
And that's a big important part here. This is not just capturing image to share with people watching the show. You are actually capturing scientific data that can be used by scientists everywhere.
We are, and we've seen totality across North America so far in Mazatlan. Now we're experiencing it ourselves, and we'll experience it after this on the Jumbotron from the other dev sites.
It's like the most amazing Eclipse train you could ever ride on.
Wow. This is a bit better than 2017.
Without a doubt, without a doubt.
No cloud.
And you know what's interesting is the crowd is quieting down. They seem to be experiencing the moment, taking it all in. A really special moment here.
Look at that. So we must be getting close to the center. Where are we at? 2 minutes? So 1 minute, 30 seconds. The corona's looking brighter because our eyes are adjusting now.
I mean, that is amazing, Bob. And how much corona you see. I mean, like just last time I didn't see that much.
Visually, oh, there goes a bat. See a bat flying over the crowd.
Oh yeah, we talked about the animals. Now we see them becoming active.
We found a Luna moth earlier as well. But that corona is about 4 times the diameter of the sun. That is massive.
That is amazing, Bob. And I'm really curious about that prominence at the bottom.
Have you looked yet, Blair? You have to look.
I haven't looked.
So take a look. So Blair's looking through the scope now.
Oh my goodness!
Totality.
I know that one right at the bottom is significant, Bob. It looks like a coronal mass ejection, but don't fact check me on that because I'm just a novice. But there's actually 2 on the bottom. Bob, you got to look at that. Yeah. There's 2. Look at the
30 seconds. William.
30 seconds left in totality. Jump in there. Take a look. It's great because we have telescopes out here for people to look at and actually see total eclipse through it.
Corona.
And
we're getting close.
I don't know what you guys are seeing on television, but
10 seconds. We got to cut it off.
Okay, all right, here we go. 10 seconds before we need to put our glasses back on.
Okay.
Oh, sorry.
You're good. You're good. We put the cap back on the telescope to make sure nobody looks.
What an amazing event, Bob. There's the diamond ring. There's the second one. Oh, snap. Oh, that's amazing. It's like it was scheduled.
Yeah, somebody had the timing right here.
Oh
my
man,
God.
it's amazing.
We will see shadow bands again here.
You hear the crowd. Everybody's excited. There we go. What an amazing moment here at Saluki Stadium.
Oh my gosh.
With Bob Baer and 10,000 fans, all loving every moment of it. Bob, some final words.
Well, I think we just had an eagle fly over.
Okay, so
but incredible.
Well, that's one of those things you said. We saw animal reaction, we heard it, we felt it.
It was wonderful. So we got to keep an eye out for shadow bands. We're going to see them again in about 1 minute on the ground here.
Okay, so we'll keep looking for those shadow bands on the ground, but I got to tell you guys back at the studio, I know you guys have seen eclipses already. There's still some to come, but what an amazing moment. Back to you guys. Good weather all the way to the end.
Thank you, Blair. We are in Indianapolis. We are almost at totality. With me, I have Nikki Rail, the Associate Director for Flight Programs for the Heliophysics Division, and Denise Hill, NASA's Outreach and Communications Lead for the NASA Heliophysics Division. You guys, let's get our glasses on. And you can hear the crowds start to roar as everyone gets on their glasses. We are so, so close. Ladies, what are we seeing right now?
I mean, just the ambiance of this moment. It is beautiful. We're just seeing a really small crescent, but the light all around us, it's so dusky.
And I'm
just odd.
It is. I'm feeling a temperature drop already, which I can't believe. It's feeling cooler. The crowd is starting to go wild.
Yeah.
We're still seeing them
Here we
crescent.
go. Here we go.
Getting
All
close.
right.
We are so
All right,
close.
and the best soundtrack you could possibly ask for in the background here.
Absolutely. Oh, we're so close.
Okay, just a little bit left, and you can really hear the crowd taking
here we
over.
go.
They
Starting to go
cannot be
wild.
more
Here we
excited.
go. Yeah, here we go.
There we go. We're so
All right,
close.
Here we go. Almost.
Almost. We are so, so close. And we.
Oh my gosh, there's that bright diamond ring. All right. Oh wow, look at that.
There it
I can
is.
see the.
Yes.
Oh my gosh, I can actually visualize the corona. I've always wanted to see that.
Wow. Look at that. Fantastic.
Oh my God, it's gorgeous.
Oh my
is
gosh.
absolutely
An incredible sight.
amazing.
And dark.
Wow.
Wow.
Look at how dark it is. Oh my gosh.
Whoa.
And you can really see those streamers coming out right now. I'm seeing some bright lights around where we're seeing cratering, and I can see those streamers coming out of the corona.
And are those Bailey's beads? Are we seeing any Bailey's beads?
We were seeing some Bailey's beads. They're transitioning out a little bit, but yes, those bright light where the sunlight is shining through craters on the moon, mountains and craters. And look at those streamers of the corona. It is putting on a show.
Moly.
And it is dark.
Holy moly.
It is dark.
I gotta take a peek at the crowd right now.
Oh, look at the crowd.
Oh
The
my
crowd is
gosh.
absolutely
Oh my gosh.
going wild. Everyone's got their phone out. It is now safe to look at the eclipse without your glasses.
Wow.
What an amazing sight. Folks, we've got 4 minutes here, a little under 4 minutes to enjoy this.
Wow.
And if you were in an open field right now, you'd be able to see a sunset, a 360-degree sunset all
Yes.
around us.
Yes,
And you
I
can see a
can
little bit of
see
that
You
now.
can see the light around us a little bit.
Yes.
I have to say, this is my first total eclipse, Denise.
This is my first total
Incredible
solar
to
eclipse.
see it.
Totality.
Wow.
This is a bucket list moment for me.
This is incredible. Really a once in a lifetime, unless you're an eclipse chaser, which I'm considering it.
I might become one after this.
I quit my job.
Wow,
Oh my
fantastic.
gosh.
Oh
We
my
spent
gosh.
so long trying to see that corona, and to see it with my eyes.
Yes.
Your own eyes. Wow, just gorgeous.
I'm just in
Oh,
awe of
yes.
being this person on this rock moving around the sun.
Yes.
I can't even believe it right now.
Yeah, and to share this moment together with 50, 60,000 people all looking up at the moon and the sun all at once. It's just an incredible experience for all the folks here in Indy and for all the folks watching. I hope you can take, the amazing energy and excitement from this crowd. What a special moment for the United States.
Oh my gosh, did you hear that? Look at this and everybody.
Oh, there we
my
go, the
goodness.
crowds.
Wow.
Wow. Okay, so I think we're seeing, yep, those beautiful
The
prominences.
corona is just putting on such a show right now. It's got my
Yes.
full attention.
Wow.
That's all I can watch.
Holy cow. We've got some very
beautiful.
appropriate music going on in the background
Yes.
here.
This is the best version of getting mooned that I have ever experienced in my life.
Don't strain your eyes.
Wow.
I am just in awe. There just aren't the right words to describe this.
I'm just noticing it feels so strange to me right now. Like I
Yes.
feel the hair on my arm standing up. I feel like it's nighttime and what
It
am I
is.
doing? And it was daytime.
And actually, folks, we are starting to get some nighttime insects coming out.
Yes, we're starting to see bugs.
Yeah, we are seeing bugs in light. It's hard to hear them over the crowd, but I can definitely see them flying.
Yes, I think the animals are a little bit confused. Nikki, while I have you, we've got a lot of programs at NASA looking at the sun. No eclipse glasses required. As the Associate Director of Flight Programs, tell me, what can we expect NASA to be sending to the sun in the next few years?
We are so lucky in the midst of this incredible time of solar max. We're getting ready to. I'm seeing a diamond ring right now.
The diamond ring. Take a look. Take a look. Put your glasses back on. Be safe. That is the diamond ring, folks. Wow, spectacular. Oh my gosh. You can even hear fireworks in the distance.
Yes.
Oh my gosh. And the light is already starting to change.
It really is.
You can hear.
Wow.
And the crowds are loving it.
Hear the crowd just loving every second of it.
Oh, what a moment. I love those fireworks. Indianapolis is really pulling out all of the stops, and we love them for it. I also want to take a moment here to thank our 2 telescope operators, John and Dana, who have been providing these telescope views for us there from Ball State University. Thank you very much to John and Dana. All right.
It's like somebody flipped the lights back on.
It's like a sudden switch flip.
This is so crazy.
And I can feel it warming up already.
Yes.
Wow.
This is so amazing.
Incredible. Well, this is an incredible moment, and an incredible moment for the Helio Big Year. Ladies, thank you so much for joining us. This has been fantastic.
Thank you for having me and sharing this.
I'm so excited to be here and to see this incredible sight.
Absolutely. Megan and Sarah, back to you.
Oh, that was so fun to experience, and I can't wait for us to do it now. Take a look at this drone shot where you can see it definitely got noticeably darker. We feel it here. It's colder. The crowd is cheering now. They're ready for totality here in Cleveland, Ohio. We are less than 3 minutes away, 2 minutes and 18 seconds away from totality here in Cleveland, Ohio. The crowd over here to our right going crazy, feeling the excitement. I'm ready for this. How are you?
Yeah, it's super cool. It's all of a sudden it's really getting dark and you're starting to feel it.
Yeah,
so cool.
It's like they just dimmed it out. Now it's like night. This happened within the last couple of seconds. But let's take a look around, because obviously we're not the only ones enjoying the total solar eclipse today. We have some we have some eclipse viewing events that we've seen around the country. So why don't we take a look at some of those? Wow, oh my gosh, so this is
cool.
Times Square. That's the NASDAQ tower, and they are taking our feed live right now, and we're seeing
awesome.
Cleveland, Ohio sun.
They're only going to get a partial eclipse today, but they get to watch our eclipse with us. So.
Yeah, I'm really glad that they can do that. Wow, look, that sliver of a crescent just left. It's actually perfect on that building,
beautiful.
The shape of that building, right? And we can see some people in the foreground taking a look, stopping to watch. It's hard to stop in Times Square, right? But they're stopping to take a look at this with us.
Beautiful.
Oh, awesome. So this is just next to us. This is Progressive Field here in Cleveland, Ohio. So the Guardians have their opening day today, and the first pitch is like after 5 o'clock. But as you can see, they've opened up the stadium, and people are in there to enjoy the
big crowd
eclipse.
in there to watch that. That's great.
Yeah, you can. Oh my gosh, it just got darker here.
Yes.
Oh my gosh, that's so interesting. And then Mentor Civic Amphitheater again. The field starting to fill, and everybody looking up at the sky for their opportunity to see today's solar eclipse. This is us back here in Cleveland. Everybody looking up at the sky. We have 30 seconds until totality here in Cleveland, Ohio. Oh my God, I have goosebumps everywhere. Everybody's starting to cheer. I might cry. I kind of feel like crying. This is so cool to see. It's getting so dark so fast.
Wow, it's like night just descended on us.
And look at the crescent slowly disappearing. Crowds cheering here. Cell phones up, cameras up. 5, 4, 3, 2, 1, and totality. Totality, everyone.
Oh my God. Oh wow. Oh my God.
I was so nervous.
Wow. I know, I wasn't sure because we had some high clouds, but oh my goodness, you can see that corona extending out. Oh wow.
Yeah, the clouds were really bothering me and really scaring me because it did get very cloudy here in the last hour and a half, but we have a great view here in Cleveland, Ohio.
Yes.
Wow, look at the corona.
You can hear the crowd. Wow, everybody's got their phones out.
Oh my gosh.
Wow. You know, I saw pictures of what the shape of the corona might look like from our NASA scientists, and it looks exactly like they predicted.
Oh my gosh. Oh, and you can see Jupiter and Venus.
Oh yeah, look at that.
So Jupiter's to the upper left of the eclipse that we're watching, and just to the right of it is Venus.
Yes. Oh, and I see some of those pink protuberances we've been talking about all day.
Wow.
Beautiful.
And again, all around us you see light, but just at the top where we are.
360 sunsets.
Exactly, exactly. Yes, Indianapolis had described that as well.
Woo!
We have totality here for 3 minutes and 50 seconds.
That is such a luxurious amount of time. I saw the 2017, I think we only had about 2 minutes. So.
And why is that? Why does the length of totality differ?
Oh yeah, well, because sometimes the moon is a little closer, a little further away. Its orbit's elliptical. And so when it's further away, it looks smaller in the sky, but when it's closer, it looks bigger, and so we get a little bit more extra time.
Look at the prominence. You can see it on the bottom. On the bottom there.
So pretty.
Wow.
It's like bright pink.
That is insane that you can see it from there. From here.
Yes.
Just like the power of our sun. I'm truly in awe right now. And cold. I'm in awe and cold.
It did drop.
It is noticeably
10
colder.
degrees. It's like, yes.
Yes. Looking around to the crowd. A lot of people videotaping it, trying to take photos.
It's the lovely backdrop of the Cleveland skyline.
Yeah, that's beautiful. We have the stadium right next to us. Oh my gosh. And again, thanking the Great Lakes Science Center and NASA for hosting this event here in downtown Cleveland, Ohio.
And it's great to like sort of join humanity to all come together at once and experience this together with such a great
Oh,
group
look at the
of
screen
folks.
right now. Here's a shot of the skyline.
Oh,
wow, the
wow.
sky looks on fire. Beautiful. A lot of excitement still here in the crowd. Sarah's just taking it all in. Sarah, you're supposed to be commentating. You're supposed to be saying.
It's so beautiful.
So you can tell that we have some cloud cover, right? It's kind of hazy here, but still.
It is, yeah, some high clouds. I was worried about it, but like we can still really see, have a pretty good view here.
Wow. And again, this is so rare for people here in Cleveland to see a total solar eclipse. The last time was 1806. The next time, guys, 2444. That is incredible.
I hope everybody took the time to come outside and witness this today.
Oh my gosh. You can still see that prominence. Again, talk to us about what a prominence is.
Yeah, so that pink color comes from the helium in the sort of outer atmosphere of the sun there. Oh, it's beautiful.
And it gives off that pink glow.
Yeah.
Wow. Totality
here
ending
comes-
here.
here
Wow,
comes
there's
that-
the diamond ring. Oh!
Time to get your glasses back out.
Time to put your glasses back on, everyone. That's your cue. Glasses back
cue.
on.
We get
Wow.
that diamond ring.
Wow. What an amazing experience. My first total solar eclipse.
Yes.
Let's see what they think about this in Niagara with Daryl Nail.
Over the entire area. You can hear the crowd erupting at various moments when the eclipse has been seen, but we are under pretty cloudy conditions, and David Sheeny is with us. He's a program executive with the Heliophysics Division. David, this is a challenging situation to be in order to try to see this eclipse. We've seen glimpses.
We have seen glimpses, so we're basically spending our time staring at the sky, hoping for a little bit of a glimpse of what would be a totality. So right now, the sky has just completely gone dark. You can see all the lights, basically, everybody's cameras and everything else are all making it lighter. And it's gotten significantly colder as well, just over the last several minutes.
And it's like, it's fascinating to see it go night like this. We've been listening to everybody across the country enjoying totality and seeing it clear. That's not the experience we're having here. In fact, it's so cloudy that our telescope operator, Jessica Bellina, who's working very hard to try to get a lock on it, has not been able to get that telescope feed dialed in because she has to have a view of the sun in order to see it. So we don't have a feed for you from Niagara. What we have is just every once in a while you'll hear part of the crowd, only part of the crowd will cheer, because I guess they kind of have an angle through the clouds to see just a little bit.
Yeah, and the clouds are really only cleared out enough occasionally to even need eclipse glasses. So for the most part, you have a thick enough layer of clouds that you can see the eclipse without them, and it's just fine. So a lot of us have been able to just take regular pictures with our cameras.
Let's take a look and just kind of enjoy the moment of darkness that we're in now. People have come from all over the world to be here.
You can see some. It looks like it's a little bit lighter up there. Our spotlights are blinding these guys. Can we turn the spotlights down? So there, oh look, you got a little bit of eclipse right there, with people watching. So we're just catching little glimpses of things as we look up into the sky. So this might not be as exciting as some, but this is what we get. We're just hoping to have a little bit of a glimpse.
Well, we've got 3 minutes and 29 seconds for it to happen. We're already a minute or so in.
Right.
We heard there's going to be skydivers that are going to jump out. Probably hard to see them.
Yeah, I don't know that we'll ever get to see the skydivers. You can't see any of Niagara Falls really. It's basically all like as if it was night for us here. You can start to see some of the light come in from the other side.
So we're taking now a view of Tupper Lake, New York. That's
oh look, there you go.
Hey,
we got totality right there.
We're
getting totality right now that we can see.
There it is.
We just got a really nice clear spot right there. So
wow,
got a little bit of hole through the clouds so everybody could see.
Just opened up. And now that was the roar from the crowd that you just heard, and just as soon as it showed.
So yeah, we're continuing to watch the totality that we're getting right now. You can see a little bit of hint on the side as it's shining through.
Well, there it ducked down.
Yep.
Jessica,
so here we go. We have another view, a little bit, another little view right here.
No.
As it's starting to peek out around.
Oh, there it is.
So we're getting starting to peek out just around right there. Yep.
Well, totality is complete.
Yep. Well, that was a fun experience to watch and hope for, like just everybody else around here, hoping for a view. And we got it.
That was a unique experience. Bring the lights up. And suddenly night is turning into light and day.
Yeah, we're getting some light again. Oh, although that's a lot of light.
I was worried there for a second that we weren't going to get anything. David Cheney, thank you so much for joining us. Appreciate you sharing this experience. I was really worried that we were going to see something. Fortunately for everybody here in Niagara Falls, we got to see a little bit of the eclipse. And
yes, we did. That was great.
Some cheering now. Thank you very much.
All right, you're welcome.
As we take a look around the falls, and people have not moved. They are still looking up, enjoying the partial eclipse now. We're going to bring in Jeremy Hansen. He is a Canadian Space Agency astronaut who has been at the falls with us for the past few days. And Jeremy, you're going to be on Artemis 2, of course, the mission. We'll talk a little bit about that.
I'm going to be looking over your shoulder here, Daryl.
Hey, make sure you put on your glasses.
Well, we're still pretty safe. We got a lot of cloud cover, but
that's true.
That was actually, I think, exceeded expectations.
Well, I mean, when your expectations start off with just clouds everywhere.
Yeah.
And I didn't think we were going to get anything. How did you feel when it finally poked through?
I felt like success because we all really wanted to see it in totality, and we might have only saw it for 5 seconds, but we did get to see it, and we could see the corona, and that was just very special for me. So I really like that. And then when it passed totality, it was like this amazing, hopefully the camera captured it, but just like that amazing sunrise just coming across the clouds. Actually, the clouds kind of made a nice backdrop for it, so that was pretty special.
That was very unique, very special. I'm so glad and a little relieved that we got to see a little bit of it. That was the moon passing in front of the sun. You're going around the moon in September of 2025, currently scheduled for that. You'll be the first Canadian to do so. You just saw a real special moment. That's another one. What are your thoughts on getting ready to take that big trip?
You can imagine I have a lot of thoughts about Artemis 2 and what Reed, Christina, Victor, and I are getting ready to undertake. But if I have to boil it down, a lot of it comes down to pride. I'm really proud of humanity for taking on these big challenges. We're really proud of the United States for their leadership, for creating this opportunity where other countries can express our genius, bring real contributions to the program. And now Canada is going to be the second country in the world to send a human into deep space. And it's got nothing to do with me. It has to do with the genius that the world is sharing. I just love that.
That's amazing. Want to mention real quick, we are in full totality up at Tupper Lake, New York, not far from here in northeastern New York. We're here in western New York where light is continuing to shine and get a little bit brighter. It really is special, and we really felt that in the 4 days that you were here interacting with the public. Was that your sense?
There's a lot of excitement around this celestial event that's happening and around space exploration in general, which I find really uplifting. I don't think space exploration solves all the problems or challenges of the world, but I do believe it is one of the pillars of those solutions. It doesn't matter what problem you're looking at, space plays a role. And I love it when I see our youth getting fired up about, asking me, how do I work at NASA? How do I work at the Canadian Space Agency? We're on the US side here, but I've had some Canadians come up to me. It's just something that brings us together. This, the spirit of humanity. Just like this experience we're having here, it's a very, it feels like community. We're all out here, just humans, just being humans and sharing something special.
And sharing it together was really neat, that communal part that you talk about. Like, I felt a little bit of a bond with everybody here now. You as well. Appreciated seeing you and having dinner of the past few nights. Just happened to work out coincidentally. Really enjoyed the time. Great words today, and we will all be rooting you on for your mission coming up in September of next year. So good luck. Be safe. We'll be rooting you and your crew on. Thank you, Jeremy.
Yeah, no, we'll take it. I appreciate that. I don't know if you saw it when you're on camera because you were busy, but the birds, they just went nuts in totality. Did you see that?
No, I didn't see it.
They're all up here. They came out of the woodwork. I mean, there's been birds all day, but it was sort of like birds filling the sky. I thought that was really neat to see. Anyway, thanks for having me today. It's a pleasure to be here.
Thank you fill that out in your Citizen Science Journal. Make sure you put that in there because we're doing that. All right, thank you, Jeremy. And I just want to say thank you also to New York State Parks, Niagara Falls specifically. We couldn't have done this without you. So thank you very much. Definitely. We're going to throw it now to Kennedy Space Center where James Traley is tracking totality at Tupper Lake. James?
That's right, Daryl. Yeah, we are still in totality in Tupper Lake. We are nearing the end of our eclipse across North America. You can see our last target of the day, Holton, Maine, is all the way up here, almost off your screen. This speed of the eclipse shadow is moving so quickly across. The ground speed is about 2,000 miles per hour, so that is a fast clip. If you're in the path of totality, really take full advantage of those few fleeting moments to observe this moment. If you're not in that path of totality, or if you missed it, hopefully you didn't miss it because we've been tracking it all day here showing you. If you did miss it, I'm going to zoom way out here and show you what to keep an eye out for in the future. So this is going to be the eclipse path in 2045. We're going to come through parts of Montana into North Dakota in 2044. 2045 is the next big eclipse across America. That's actually going to come, oops, I didn't draw here. There we go. That's going to come all the way from California into parts of Florida there. That is in 2045, so a long time to wait. So really take full advantage of those fleeting moments to be able to observe this moment. I'm going to click on Burlington here, who are also in that path of totality, experiencing that right now too. So just an incredible moment to really see all of this. And Tupper Lake, again, they're still, I think, experiencing that last fleeting moment there. That is just moving off. You can see that is officially now moved off Tupper Lake. Really a fantastic shot. They have that now, that diamond ring effect, that really beautiful shot there. This is, again, such a quick moment, and this doesn't happen very often. It's really a once-in-a-lifetime moment, so take full advantage of this. You can see just how close we are now to Holton, Maine, who are our last stop of the day on our NASA coverage here. This is then going to continue on into parts of Canada and beyond. Holton, Maine, they had some snow past couple days. It seems to have cleared up quite a bit more for them. Really hoping that that holds out for them. They are expecting a duration of 3 minutes and 20 seconds to be able to observe that totality at 3:32:05 local time. Really excited to see that view. You see that shadow creeping so quickly up to them up there. So Let's check in with Angelique, who is up there in Holton, Maine. Hopefully it's beautiful weather for you. How's it looking up there, Angelique?
James, it is looking awesome up here. We are just a few minutes away from totality. Can hear people announcing it in the back, and people are getting excited, as am I. And here to share in all of that excitement with us is actually Dr. Eric Smith, the program scientist for the James Webb Space Telescope. Eric, it's so great to have you here.
Oh, it's great to be here, Angelique. This is really exciting.
Eric, is this your first eclipse?
This is the first totality I'm going to see, so I am super psyched, and I am delighted to be here in Maine to experience it.
Yes, and so we've actually been kind of watching as it slowly gets closer and closer, right? And what are we? We're starting to feel it getting kind of cooler. We're seeing the shadows change.
Yeah, we're seeing the light is definitely different from when the sun sets and the shadows get a little diffuse. Here they're still sharp, but the light is diminishing. Your brain tells it something different is happening.
Something is definitely up. So, speaking of up, that's where the James Webb Space Telescope is. And what's interesting about the telescope is that it actually can't look directly at the sun, just like we can't.
Yeah.
Can you tell me a little bit more about why that is?
Sure. We designed Webb to look for very faint things in the distant universe, so it's very sensitive for very faint things. Of course, the sun is very bright, and so we had to make sure that it could never look at the sun. We use solar power to power the spacecraft, but the telescope can't look at the sun.
That makes a lot of sense. Now, as it's starting to get a little bit closer to all of the cool phenomenon, the Bailey's beads, the diamond, let's go ahead and put on our glasses.
All right.
So that we can look up and continue chatting. Wow.
Oh, just a little tiny
Just a little bit left. That is incredible. Wow. So, Eric, I have a couple more questions for you. Another thing that I was wondering about is how we can use actually eclipses to study exoplanets, which are planets outside of our solar system, using, I think, the transit method. Is that what that's called?
Yeah. Right now, during an eclipse, the moon...
Sorry, you can hear everybody getting excited. We're getting very close to totality here.
The moon is transiting in front of the sun just the way planets that orbit around other stars transit in front of the star. So Webb can look at those exoplanets and use the transit just like we're staring up at the moon transiting the sun.
Gotcha. And so a transit is, like you said, literally just when something crosses in front of something else. That's
right,
transit. Yeah. Okay. Very cool. So throughout the broadcast, we've actually been able to see the eclipse through different telescope feeds. Can you tell me a little bit about what the difference is between, actually, we're going to go ahead.
Oh, here we go.
We're getting really close. Oh my gosh, it looks like just a few more seconds until we are in complete totality. Oh my gosh. 6, 5, 4, 3, here we go.
1.
You can hear everybody cheering. This is incredible. So let's go ahead and take off our glasses. We are in totality now.
Oh, you can see the coronal spikes. Amazing.
That is
beautiful.
Incredible.
You can see a planet in the sky that you couldn't see before.
Oh, wow. And I think, is that one of the, oh gosh, the
there's some drone. There's
now.
A drone up there in the sky, too.
Oh, my goodness.
Oh, wow.
It's incredible. The rays that you can kind of just see coming off of the corona.
Yes, yeah. Stunningly beautiful.
Yeah, that's got to be one of the most amazing things I've ever seen.
And you can see the gradation in the sky color down to the horizon,
Oh,
too.
my goodness.
Yeah.
I am seeing a bit of that 360-degree sunset.
Yes, yeah.
That is really cool.
It's amazing. Even though we're in the total shadow here, there's still the corona is still pretty bright.
It is incredibly bright.
You could read by the light of the corona.
I think I would have some trouble reading, but I probably could. I could technically read something. So, Eric. Oh, and actually, we have the International Space Station flying over right now, so they are actually seeing not one, but 2 views of the eclipse. They're able to see not just the moon passing in front of the sun, but they're also able to see the shadow of the moon passing over Earth, which is absolutely incredible. I mean, I can hardly imagine a view being better than the one we have right now, but if there is one, it's
probably on the space station.
It's from the space station for sure. Wow. So, yes, they're able to take some pictures of that, and that is just incredible. Just incredible.
One of the things they told people to do if you're far away was to hear how nature changed. And it was interesting here. We're, of course, surrounded by a lot of people just to hear their reaction when we went into totality.
It's true. The humans in nature have not gotten quieter, but louder, I would say. But, I mean, you can definitely hear the loudness has a different kind of character to it. There's almost like a, I mean, I don't know if wonder has a sound, but I think this might be it. Yeah.
Hushed awe.
Yes, hushed awe. That's wonderful. And I can see just one little red, I guess, like protrusion coming down
little
there.
red spots almost. I noticed those too.
That's cool. Now there are two.
Yeah.
Wow. That is just so cool.
Yeah, I like the 360 sunset. It's a little hard to see behind us, but it's...
oh, we've got at least one or two drones.
Yeah, some... our robot overlords.
Of course. And so, Eric, I know that, I mean, clearly with the drones, people are starting to get involved in the eclipse, and I know that there are lots of ways that people can actually get involved. One of those ways is with citizen science.
Right.
Do you mind talking about some of those opportunities, how people can actually...
Sure. We had citizen science programs where people could use their cell phones to take pictures during the eclipse. And
we're getting ready to come out of totality. We're just put our glasses on.
And here we go. But those oh, there it is. Oh, it's peeking out. Oh.
Everybody is cheering. We have just made it to the end of totality. We're starting to see the sun just peeking back out again.
Now just look at the ground, how much brighter it's gotten.
It is already so much brighter. That is so wild. That was probably one of the most amazing, but also fastest 3 minutes of my life.
Yeah.
I wish I could do it all again.
Yeah.
All right, well, that was incredible. Incredible to get to experience that here in Holton. Thanks so much to the city of Holton, and also thank you so much, Dr. Smith, for coming out and hanging out with us and experiencing this wonderful event.
Oh, it was my pleasure, and congratulations to the city of Holton here for doing such an amazing job covering the eclipse. It was amazing how well orchestrated it was.
Above and beyond. Yeah. And I want to say, of course, a special thank you to photographer Dave Bowman, who has been giving us these incredible images from the telescope feed, and we're gonna enjoy as the rest of the eclipse kind of ends here, going back in the direction that it came, and with that, we're gonna send it back over to you, Megan.
Alrighty. Thanks, Angelique. So, Gina, I mean, what do you think? Like, we literally have just watched the eclipse travel, what, about 2,600 miles?
It's going across
Mexico to Maine.
Yes.
In like, what, about 88 minutes?
That's right. It's
so
like
fast.
that 1,900 miles per hour that the shadow's traveling.
I mean, did you have a favorite location?
For me, I think between Russellville and Dallas, just getting to hear some of my colleagues and their excitement too, it was amazing.
Oh my goodness, yeah, no. So, I don't know, I have to be a little bit biased. We did have some cloud cover here,
we did.
But to see it with your real eyes was just...
And we had that moment, which was
We did, yes. It was amazing. And so it's really cool too, just to think about how millions of us now have this shared moment of what could be a once-in-a-lifetime event.
It's true.
And so, folks, we have time for some more questions from our viewers. And again, we have another great question from Mackenzie, who's in the 3rd grade.
Okay.
Let's roll it now.
Hi, my name is Mackenzie. I am in 3rd grade. My question is, what is the difference between a lunar eclipse and a solar eclipse?
Thank you for that question, Mackenzie. Okay, let's talk about the difference between the eclipses. Now, the solar eclipse that we had today is when the moon crosses between the Earth and the sun. But we also get lunar eclipses, and a lunar eclipse occurs when the Earth crosses between the moon and the sun. So it's really about where the shadow's going. Today, we have the moon shadow projecting on the Earth. During a lunar eclipse, we have the Earth shadow projecting onto the moon. So that's the main difference there.
That we just saw, too, those incredible views from space,
That's
you
right,
know,
from
to
the
see
space
that
station.
second perspective view. And
Yeah.
so I've got another question for you right now. It's going to be Eli on Reddit, who wants to know, there are quite a few solar eclipses in the world every few years, so why is this one scientifically interesting?
Okay, so yeah, we do get solar eclipses and lunar eclipses maybe 2 to 3 times a year. However, the total eclipse that happens today, total eclipses are about every 1.5 years. And that is a rare opportunity for us to look at the corona, study the corona in a way that we can't do during the other types of solar eclipses that we have. So
and during a solar maximum.
Exactly, during the solar maximum. So for this one particular, you know, we were talking about the solar activity that we were seeing on the limbs during the totality. Yeah, there's just a bunch going on today for this eclipse.
And so too, right now we've got another incredible view.
Oh, look at that.
These are live views from space, which is just mind-blowing in general. And now we're also to see the moon's shadow across the Earth.
Wow.
It is just amazing. So, you know, Gina, too, thinking about how many people across North America today witnessed this one moment, it's a good reminder that humanity has been experiencing these eclipses for centuries. And, you know, there are different meanings for these events in different cultures. Let's check in with Joy in Dallas to learn more about indigenous astronomy. Joy.
Hi, and welcome back to Dallas, Texas. I'm with Dr. David Begay. He's an indigenous astronomer and also a member of the Navajo Nation. David, thank you so much for joining us. So when people think about science, they might be thinking of Western science. So David, how does that relate to indigenous science, and what did the total eclipse mean to the Navajo people?
I think the knowledge on the eclipse goes way back. From time immemorial, I'm told by my elders. And they knew that when you look at the sun directly, you can damage your eyes permanently. And so they knew that about the danger of looking at the eclipse with the naked eye. So people were encouraged to go inside to ensure that people weren't looking up, especially the kids. So it goes way back. And as far as eclipses, it's a time of renewal, the sun alignment with the moon and also the earth alignment. The whole cosmic cycle goes through a regeneration process. It revitalizes the process. And so it's a gift that goes on. For many years, over and over. It's a cycle. And as far as science goes, there's different definition of science.
Thank you, David.
Maybe we can cover that.
Thank you. It's been an honor chatting with you. So thank you to everyone here for joining us. Thank you for the Arboretum for hosting us. For this very, very magical moment. This has been an experience of a lifetime and one that I definitely won't forget. So let's head back to Tahira and Gina in Kerrville, Texas.
Thanks, Joy. We're joined now by Jamie Favors, the director of NASA's Space Weather Program, to tell us more about some cool science that launched today during the eclipse. Welcome, Jamie.
Thanks, Tahira.
Hey, Jamie.
Hey, how are you?
Good. And so can you tell us, why did NASA launch rockets before, during, and after the eclipse today?
Sure, so it's really to capitalize on this really unique situation. You know, things like this happen every day, you know, going from daylight to, you know, sunset into, you know, darkness. It happens so quickly that we can make these measurements, one right after the next, to really understand very precisely what's going on in the atmosphere. With sounding rockets, we can do that so quick back to back, the way we can't do with some of the really large rockets.
Okay, so Jamie, how high did the rockets actually go, and what's special about this area of the atmosphere?
Sure, and we just launched the second of those three just a few moments ago, and that's going pretty well so far. These particular rockets are getting about 250 miles above the surface, pretty close to right about where the International Space Station flies. And before you ask, everything's safe. We take care of the.
And it looks like we've got a playback of that right now. Oh, wow.
Perfect.
Can you walk us through this?
Sure. So from Wallops Island out in Virginia on the Virginia Space Coast. So these rockets have multiple stages to them. So you're seeing one stage burn for a few seconds, then that drops off, and then the next stage will light to eventually take it all the way up to about that 250-mile mark above the surface to make those measurements in the upper atmosphere.
Wow, that looks incredible.
Yeah.
Oh my gosh. Okay, and so what is that area of the atmosphere, and why do we care about it?
Yes, it's the upper part of our atmosphere. It's called the ionosphere. That's really from a perspective of heliophysics, where we really see a lot of that interaction with the sun and the earth. We care about it because that interaction can change the way our GPS signals work, our communication signals work, and even up a little bit higher, we start to see the influence of the sun actually causing the atmosphere to change its density in a way that can impact the way satellites orbit the Earth as well.
Sure. Okay. Great. And so, Jamie, today we've been doing this fun poll, you know, to see who is Team Sun, Moon, and Earth. What team are you repping today?
Well, other than Team Science.
Don't choose the wrong answer.
Well, my bosses would make sure I go for Team Sun today for sure.
Oh, man. Okay. Well, thank you so much again. Thanks, Jamie. And folks, it is time now to say goodbye to our friend, James Traley, who has made sure we've known where and when to look up all day. James, thank you.
Yeah, thanks so much, Tahira. It's been fantastic tracking this eclipse across North America all afternoon with you. If you're still in the path of totality, you might be in a boat somewhere off the Canadian coast taking this all in. I hope you enjoy that view, that fleeting moment. We've made a big journey across. I can zoom out here on our eclipse board. You can see we started all the way down here in Mazatlan, Mexico. We've trekked all the way across and are now, like I said, breezing past Canada now into the Atlantic Ocean. It's been fantastic to track this. And if I turn on the shadow of our penumbra, you can see this highlighted area. Anywhere in there is still experiencing a partial eclipse. So if you're in that partial eclipse area, be sure to have your eclipse glasses at the ready so you can take in that fleeting moment. We just went outside a few moments ago here at Kennedy Space Center to take it in. It's fantastic, beautiful view. It's really cool to see. You got like a little chunk out of the sun there for us here, only about 50% coverage, but still fantastic to see. So really, it's been phenomenal. We've lucked out in general with the weather all of today too. That was the biggest concern I had going into the day here. It's been beautiful views up and down here, and so really fantastic to see this. Really been a lot of fun tracking this with our Eclipse Explorer. A big thanks again to our scientific visualization studio for putting this tool together. But for now, back to you, Tahira.
And here with us now is NASA Chief Scientist, Dr. Kate Calvin. Kate, welcome.
Hi, Kate. Hi, nice to be here.
So happy to have you back here again. I know we had the pleasure of sharing the stage together for the annular eclipse.
Right.
Now, with today's total solar eclipse, can you tell our viewers what would you say is the #1 takeaway from today's events?
I would say the #1 takeaway is that our universe is beautiful and understandable. We all got to experience this together today. We could predict when it would happen, and we did a lot of science today.
That's great. So speaking of the science that was conducted, you know, how does that fold into kind of the greater science that we're doing with NASA in the future?
Yeah, so we did a lot of science today, and a lot of it really complements science that we do all of the time. So one of the things we were really looking at today was the corona. The moon blocked out the sun so that we could see that part of the sun's atmosphere. But we also have a mission called Parker Solar Probe that's orbiting closer and closer to the sun so that we can study the corona with that. We were also looking a lot at how the eclipse affected Earth. So we had a citizen science project that looked at how the eclipse changed temperatures and clouds. We have a mission that launched 2 months ago that's studying clouds all the time, a mission called PACE.
Awesome.
It'll tell us more about oceans and atmosphere on here on Earth. And one of the other things we do is we develop instruments called a coronagraph. So the moon blocked out the sun today so that we could see that corona, but we can make an instrument that does that. And so we have an upcoming mission called Nancy Grace Roman that's going to block out the light of other stars so we can see what's flying in here around them.
Amazing. So much going on for the sun at NASA, honestly.
Right.
And you know, I understand that the Heliophysics Division has a big sun celebration going on right now, the Heliophysics Big Year. Kate, could you tell us how we could get involved in this and really just celebrate our star?
Yeah, this total solar eclipse was just one event in a series of this Heliophysics Big Year. We're working towards Parker Solar Probe's closest approach to the sun, and we have a lot of activities where you can engage in our science and learn more about the sun. And if you want to know more, you can find us on social media at NASA Sun.
Fantastic.
Wonderful.
Thank you so much, Kate, for being here with us. It was really special to share this moment with you.
Thanks, Kate.
It's nice to be here.
And Gina, this has been an honor. I mean, my goodness, like to have the annular eclipse with you, then to share this total solar eclipse with you.
I know.
Thank you so much. And do you have any final thoughts?
You know, this was amazing. Annular was great, but to hear the energy here,
the total was
so
just
great
a whole
to be
nother
with
level.
Both of you, you know.
Yeah.
Once again, thank you for having me.
Absolutely. And you know, a big thank you to the city of Kerrville, Texas, the Parks and Rec team, and all the people that made today's incredible event possible. I also want to thank our telescope operator Catherine Troach, for those great views of totality here in Kerrville. Folks, That is a wrap from Kerrville, Texas. Back to you in Cleveland.
Thank you to Hira and Gina, and also Kate Calvin. And now check out who we have here at the host desk, the Pastronaut himself, Josh Dobbs, who just signed on as quarterback for the 49ers. How do you feel about that?
I feel good. I feel good. It's exciting times. Obviously, I spent a couple years here in Cleveland. Got a chance to have some fun over at NASA Glenn during my time here. So it's cool to be back and take in the Eclipse Fest here in Cleveland. But looking forward to the future in San Francisco. I know NASA's doing some great work out there on the West Coast, so we'll be able to stay tuned to that as well.
Yeah, so for people who don't know, the Pastronaut nickname comes from some incredible plays you had last year, and also you have a background here with us at NASA with some externships, but also you're an aerospace engineer. So how did it feel being back here specifically in Cleveland to watch the total solar eclipse?
It felt really good. You know, when this event was put on my radar about a year ago in last off season, they're like, hey, like the eclipse is coming straight through Cleveland. We'd love to have you here. It's going to be a once in a lifetime event to be able to experience it, especially right here on the beautiful Great Lakes, and obviously have some great weather today. So I marked on my calendar a year ago, and to make it back here and take it in, you know, and get a chance to hang out with the city I spent 2 years in, it's been great. I think like the biggest thing that I've enjoyed is just seeing the interest from the city of Cleveland and how many people traveled here to take in the event today, and to be able to then also go learn about the future of NASA and the future of space exploration as well at the same time. It's a once-in-a-lifetime opportunity to take it in, and it's been an honor to be here.
So, you know, Josh, NASA is really committed to inspiring the next generation through discovery. Do you think maybe we created a few new future scientists and engineers here today?
I think so. I think so. There's a wealth of youth walking around here and taking in not only obviously the blow-ups and the displays outside, but also the Great Lakes Science Center inside, and just seeing the history of the space program. I think that gives them perspective. And so that's just like NASA, that's been my approach. You know, I think the youth obviously is the next generation. They're going to have a tremendous impact on the world, and being able to inspire the youth out here and the youth across the country that if you have interest in STEM and also are really good at sports, you don't have to split your eggs into, you don't have to split up your eggs, right? Like you can go out, put all your eggs in both baskets and work hard to achieve those goals and dreams.
Now, Josh, we have time for one other question. It's the most important question we're going to ask you.
Okay.
Who was the star today? Was it the sun, the moon, or the earth? Say the right thing, Josh. Say the right thing.
Drum roll, drum roll. The star of the day was the moon. I gotta go with it. I gotta go with it. I gotta go with the moon.
I agree. I do. All right. Well, I appreciate your honesty. Right. I appreciate your honesty, and I really appreciate you being here. Thank you so much, Josh, and it was great to have you here with us.
Thank you guys for having me.
All right. So we talked about this controversial but friendly competition. So actually, we asked you guys to vote. We have the results of that poll right now. Let us bring it up. Whoa!
Hey.
All right. Congrats, Sarah.
Come on.
Congrats.
Thank you.
Team Earth, 26%. Team Sun, 26% as well. But Team Moon, 48%. Congrats, Team Moon.
Go
today.
Team Moon.
All right, again, thank you to everyone who participated. We were the real winners of today, though, those who got a show. But we're going to send it back over to Indianapolis for another really important interview.
Thanks, Megan. We are back here in Indianapolis. It has been an incredible day, and it is not over yet. With me, I have Jake Bleacher, the Chief Exploration Scientist for NASA. Jake, welcome.
I could not be happier to be here.
How was that eclipse for you, really quickly?
That was amazing. It's getting warm again. I still have my fleece on from when we were in totality.
That was incredible. Well, today has been all about the eclipse, all about the sun's light. And I want to pivot a little bit here because you're getting astronauts ready to go back to the moon, live and work there for the first time in 50 years. How the sunlight shines on the moon also very crucial to what we're trying to do there?
Yeah, well, just like this eclipse, it's the celestial dance between the sun, the earth, and the moon. And when we go to the moon, we'll actually have instances of eclipses where the Earth will eclipse the sun.
Wow.
So it's something to think about. But we're really interested in the lighting in the South Pole. Our Artemis 3 mission will land astronauts at the South Pole. And there, because the moon has almost no axial tilt, the sun is always right along the horizon.
Wow.
And so high peaks have sunlight more than normal amounts of time, and low depressions have almost no sunlight or never see the sun. And so we think there might actually be water trapped there.
Incredible. So one thing that we've talked a little bit about on the broadcast is space weather. And space weather is really important to understand, especially when it comes to the safety of our astronauts. Can you describe how the instruments Ursa and Hermes are actually helping keep our astronauts safe?
Yeah, Ursa and Hermes are payloads, science instruments that we'll have on our gateway. Gateway is going to be a station, a research station that orbits the moon, and astronauts can stop there on their way to the surface of the moon. And these payloads, or these science instruments, will be there to basically detect what the solar weather is like, what we call space weather. So that radiation that our astronauts will live in when they're actually there. So understanding your weather is the best way to be prepared for it.
Absolutely. Well, you've given us a lot to be excited about. Jake, thank you for being here on this incredible day.
I would not have missed it.
Well, folks, that is all we have from Indianapolis. Thank you for joining us. It has been a wild ride, pun absolutely intended, and we've had an amazing time. So from all of us here, back to you guys.
Thank you, Lauren. I did enjoy your pun. And now back here in Cleveland, we are joined by Jimmy Kenyon, director of NASA's Glenn Research Center. Thank you for joining us and for hosting us, really.
Absolutely. Thanks for having us here.
Well, so yeah, Glenn Research Center is right here in Cleveland,
Yes.
just down the road. The only NASA center in the Midwest, the only one in today's path of totality. Literally everything aligned for us to get a great show here.
Absolutely. And it has been such a great show here. You could not have asked for better weather. And it's springtime in the Midwest. That's always a little bit of a debate, but you could not have asked for better weather. What a great outing. We're here with our partners at the Great Lakes Science Center, and which hosts our visitor center, so where the people are.
Yep.
And just a great opportunity to have everybody here and connect them with what we do.
Yeah.
Yeah, you hosted this wonderful 3-day event here and invited the community and all your visitors in to come and explore and learn a little bit about Glenn. Why was that important to you?
It's important, but, well, as you know, having a total solar eclipse pass over your community is, for most people, a once-in-a-lifetime opportunity. But to have a total solar eclipse pass over a NASA community like
Right.
Cleveland,
Right.
that's even more rare. But what it does is it creates such a great opportunity to connect people with what we do. Everybody is here paying attention to our planet, paying attention to the moon and the sun, and how all of these things work, our solar system and our universe, and that just gives us a great opportunity to say, this is what we do.
Right.
And connect people with that. And that's, you can't pass that kind of an opportunity up.
Right. And speaking of all, like you said, the science, all this discovery that we're enabling today by the eclipse, you know, let's talk more about the science, you know. I know that nothing flies without Glenn. That's what you love to say, Jimmy.
That's
so
right.
Can you explain the center's critical role within NASA?
At NASA Glenn, we work on aircraft propulsion, spacecraft propulsion, power for both aircraft and spacecraft, communications. We also work on materials and testing in extreme environments, but our core competencies of power, propulsion, communications. No aircraft and no spacecraft flies without those three things, and they never will. And so NASA Glenn is literally part of virtually every NASA mission.
Well, Jimmy, thank you so much. I really appreciate you being here and, again, hosting us. This was a wonderful event. I know so many people joined us here and really enjoyed it because we were watching. We were looking out at the crowd.
Yeah.
Lots of smiles. So
Yeah.
really, thank you so much, you and the Great Lakes Science Center.
And thank you for being here and being part of this with us and really putting NASA and NASA Glenn on the map here for us.
Thank you, Jimmy.
Thank
Thanks so
you.
much. Have a great day. All right, and a big thank you to our whole team positioned across the path, from our correspondents to our experts and our telescope operators. We couldn't have done it without all of you. And Sarah, as we're taking again this aerial shot of the Great Lakes Science Center, so beautiful. Such a wonderful way to experience my first total solar eclipse, and I hope you had a good time too, because I know this isn't your first total solar eclipse.
No, this is my second, but it was really great and special to be able to experience it with you and all the folks here.
Yeah, we did notice that people right after, the people were like, whoa, they were trying to get out. There's a lot of really fun events happening in Cleveland, so there's a lot of people in downtown. So I hope that they took some time to look up today and really enjoy what they saw.
Yeah, and not only all of the great views that we had, but we also really did some cool science today too.
Yeah, really, really cool science. And actually, yeah, let's talk about that. You know, NASA's heliophysics big year isn't over yet. You know, we had the annular eclipse, then we had the solar eclipse, and now talk to us about what's happening in December.
Yeah, coming up on Christmas Eve, in fact, Parker Solar Probe will make its closest approach to the sun, 3.9 million miles, which still seems like a long way to me. but apparently that's actually pretty close.
Yeah, I can't believe that's happening. Again, just that it's all, we've been saying this all day, aligning. Everything is aligning for us to have a beautiful show. And so, yeah, you know, Sarah, again, thank you so much. You know, we watched this together, race across Mexico to Maine in only an hour and 28 minutes. And again, we have so much more to look forward to. So we hope you all stay with us as we continue studying our sun and how it affects us, from all of us here at NASA, where we make air and space available for everyone. Thank you for watching, and enjoy the rest of your day.
We are one of 100 billion stars in a vast galaxy, but for all of human culture on Earth, one sun that nourishes us all.
That is what stirs humankind. That's what unites us.
Experience the wonder, the beauty, and the power of our star.
One sun across space, time, and culture.
Let us continue the quest to unfold this universe. And let us continue to find unity in our discovery.